Net and IP version 4 network, which, if I remember correctly, required splitting 20/24 network. /24 network into 4 subnets, right? Equally sized. So you split them into 4, and remember when we split an octet, we begin with 256 addresses, and if we split them by 4, then we end up with 64 each. Yeah, so times 4 networks, and well, we need to deduct 2. Remember, the first and the last are reserved, so actually you've got 62 usable addresses per subnet, and times 4, and that's what we did last time. And yeah. So I think I didn't mention that. Just give me here. All right, so I think this is suitable slide. So with the you remember the formula 2 to the power of n, where n is number of bits. That gives you the number of networks you're going to create. Not network, not number of networks. I meant a number of n devices that you can fit within a given space, right? So if you have 8 bits, 2 to the power of n, 2 to the power of 8 gives you 256 addresses. So obviously here you've got 2 to the power of 24, which is 16.7 million. And here you've got 65 and half thousand. So, but what I didn't mention, I think, that the same formula applies to these bits, yeah? So it doesn't matter which bits you can't count. So, and if you start with this network, so this is your network, right? And then you your task is to create multiple subnets by using the second octet. And the entire octet will be given to will be available to create new networks, right? So so this is still, this space will be given left for devices, for the end devices, but this is the second octet where you're going to create those subnets. So if this is the task, right? So originally you've got /8 network, whichever it is. And then you are going to use the second octet for your subnets, for your newly created subnets. So 2 to the power of n applies to this as well, right? So 2 to the power of n, which is 8 in this case, yeah, 8 bits, 1, 2, 3, 4, 5, 6, 8, gives you 256 networks. All right, do you understand? So if this is your starting point and this is your network, one network, and then you have going to split that network into subnets, and this is where you split it. So you're going to use this second octet into for new subnets. So this is how many subnets you can create by using the second octet, right? So 256 subnets out of one network. And if you get something like this here, so your starting point is 24 network, yes, /24, and then you borrow 1 bit, yes. So this is a subnet bit, and you are creating 2 networks. How do you know this? So 2 to the power of 1, that is 2 subnets, isn't it? If you if you use 3 bits, 2 to the power of 3 will give you. Second, let me admit. 2 to the power of 3 will give you 8 networks. Yeah, 8 subnets. So basically here, this is your starting point. Yeah, you got /24 network, and you begin with that. You borrow 3 bits, and 5 you're going to use for your devices, for host IDs. So,
Morning.
good morning. So for networks, you've got 2 to the power of 3. For devices, you've got 2 to the power of 5. Well, minus 2. But you can see the simple math. Yeah. So this will always be 8 together. Yeah. So 2 to the power of 3 times 2 to the power of 5 still gives you 2 to the power of 8, right? So 3 plus 5 equals 8. This is 8. Yeah, so just remember that. It's quite useful. So you know how many subnets you're creating, and you know how many each of those newly created subnets or may contain devices. Yeah, same formula, 2 to the power of n. And now we can do this bit. Subnet a /16 and /8 prefix. So if you are, this is how you begin. Yeah. Go on. Yeah. 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 No, because networks do. Yeah. No. We only do this for hosts to understand. So -2, where did it come from? So -2 comes from if you have 32 IP addresses. Yeah, 32. First and last, you cannot use. They're not usable. They do exist, but you can't assign them to IP address to devices. This is where these two come from, but with networks, no. Just you create 8 networks, and all of them are usable. There is no limitations of any kind. No. So you have your 8 subnets, and you will have your 8 subnets. There is no need to exclude any of those subnets for whatever reason. Which is 32. Yeah, 32. Yeah, you take 2 because first is reserved for network address and the last for broadcast. So they do exist. They're still part of the subnet, but you can't assign them to end devices because they're reserved for other purposes. Yeah. Subnet a /16 prefix. So this is your starting point. You've got /16 now network, not 24 like in the first example. And so your subnet is /16 or 255.255.0.0. That's where you begin. And then you have now third octet. Well, third and fourth actually here to create subnets. So if your starting point is here, /16, then you have 2 octets, right? These 2 for subnetting. And you begin with borrowing 1, So creating two networks, and each of those two networks will, well, you begin with 65,536. Yeah, if you count all of these bits, yeah, so 2 to the power of 16 gives you this number, 65,536. Then you create, if you move your subnet mask to the right, you do exactly the same. You create two subnets. You're basically splitting all of this in the middle, yeah, and so if you halve that number, you will come to 32,768 minus 2, which gives you this 32,766. If you move subnet mask one more bit to the right, you create four subnets. So 2 to the power of 2, four subnets. And effectively, well, what you're doing, you're splitting this into four now. Yeah, initially you've got 65,536, and then you're splitting them into four. And that's where this 16,382 come from. You can calculate it that way, or you can calculate it just simply by 2 to the power of 14 minus 2. Yeah, and that it will give you that number, and so on. You go on, and until you fully used your third octet, and now you have created 256 subnets. That's how many you can have in one octet, isn't it? 256 subnets. And each of those subnets will have 254 devices, maximum number. Yeah, 256 minus 2. This comes from here. This is your host space for hosts. So this is space for subnets. This is space for hosts. And then you can continue moving on and to the right until you reach /30, when you, well, practically you can't just move. You can't use /31 because it doesn't give you any space for hosts. Yeah, so you're left with 0 hosts in such a network, /31. All right. I just would like to mention, we saw /32 before. If you remember, when we looked at routing tables, show IP route. Remember, there was a connected network with C and L, which I identified the local interface, and that L always ends up with this /32. The /32. Basically, /32 means just one single address. So to show that it is just single address, and that's what happens. Yes, so the network /32 means it's just one single device. This is the meaning of that. You will see this /32. It doesn't mean it's a network. But it is technically a network. But what it actually shows is just it is showing just single address, nothing else. Yeah. So it is possible to basically to go to see something higher than /30, like /32, but it doesn't mean that it's a network. It's just single IP. But if you want to, if you want to create some subnets, this is how far you can go practically, right? /31 doesn't make sense because it won't have any IP addresses left. And subnet masks will look, if you translate this is 128. Yeah, if you translate it into from binary into decimal, this is what it is. And remember, this is just a representation of this. This is what we deal with, and this is one representation. This is another representation of subnet mask. So this is 192. This is 224, 240, 248, 252, 254. when you've got 7 and then 255, this is /25. Sorry, /24, and then 25. We already know all of those, yeah. So quite simple, I think. I don't know, but you can have basically if you begin with /16, you can have yeah, that this is how many subnets you can have, from 2 up to 16,000 and a little bit, yeah. So you can have 16,000 subnets. That is which will, each will have a 2 IPs. So if you have a, now let's look at some practical examples. If you aim your task to create 100 subnets, yeah, so you've got a /16 network you given by your manager, and they tell you create 100 subnets. Where at what point you need, what do you need to select? Yeah, which is suitable, which will satisfy your conditions, yeah. So which you need to select here, which subnetting. So and from so if you yeah, so this is your beginning, 172.16 and /16. So this is your subnet. So this is your network, and it is /16, like so. And where do you which one do you need to select? Where do you stop? Yeah. So if you start borrowing, going right, borrowing, how many bits do you need to borrow? So, well, clearly, if you borrow 6-bit, and this will allow you 64 subnets, yeah, to the power of 60 of 64 is not good enough. But if you borrow 7, you will create 128 subnets, and this will satisfy your need. Yeah, so this is where you what you need to select. So 128, and you need to have 300. This will be good enough. Yeah, Nana, you wanted to say something? So the task will look something like that. Yeah. So you're given this network, and you asked to create 100 subnets. So how many bits do you need to borrow? And you need to borrow 7 bits. 2 to the power of 7 gives you 128 subnets, and that's this is good enough number. Yeah. So 128 with higher than 100. So you will have your 100 subnets. And if you are now creating given a network which has 10 8 prefix, yeah, so it can't be 100, it can't be 172.16, right, because it's not it's a 16 prefix network. It's class B. This one is class A. Remember, we have class lists, but we still can refer to this network to when we talk about 8 prefix. So it equals kind of class A. Yeah. So when we say class A, we mean that the subnet mask is 8 bits. Yes, it's 8-bit long subnet mask. That's what class A means. So this is your starting point, and your task here is to create 1,000 subnets. And well, again, how many bits do you need to borrow? Blah 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 blah. You start with 1, and then eventually you come to 10, and this will give you 1,024 subnets. And this is where you stop. This is how many bits you need to borrow. You need to borrow 10 bits. Right? This is your initial subnet mask, 8, and then you need to extend it this way up to here. You need to borrow 10 bits, and so this will be your subnet 1,024, and this will be your space for your devices. each of those subnets, right? Which will be crazy large number still. So you've got how many bits? You've got 8 plus 6, 14, which is what is the number for 14? It is a big number. I think it's 4,000. No, sorry. It must be so 496 is 12, and 13 is what? 8, 192, right? And this will be 16. Oh, right. So no, can't be. Yeah, 384. So this is so this is 2 to the power of 14. Yeah. You're right. Sorry. Yeah, got me thrown a little bit. Right. Video. So let's do a video. Let me find it.
In classless subnetting, we've seen how we can borrow bits from the host portion of the subnet mask, and that the last one that's borrowed is the magic number, meaning that the last one, if we look at the place value of the 8-bit grouping, the last one in this case is in the 32's place, so the networks go up by 32. Starting with the 0 network, we have the 32 network, then the 64, 96, 128, so on and so forth, but the networks go up by 32. What about when we're subnetting from a Class A or Class B network address and subnetting generally in the other octets? Let's take a look at another example. This time we have a 10.0.0.0 network address and a classful Class A subnet mask, and we're going to subnet it. So we've taken the 8 bits and borrowed 3 bits, and now we have a /11 subnet mask. The last one in the subnet mask is still in the 32's place. If we look at this 8-bit grouping in this octet right here, the last one is still in the 32's place. So the networks will go up by 32. So the networks are the 10.0, 32, 64, 96, and they're going up by 32, but in the second octet.
So you understand, yeah? So you just apply the same principle with magic number, but now only to that octet. Yeah, so 32 increment. So beginning with 10.0.0.0, then 10.32.0.0, then again plus 32, 64, 96, right? And each of those subnets will have crazy large number of devices. Yeah, so it's like how many bits? 16 plus 5, 21 bits. So that each of those subnets, but it doesn't matter. So magic number rule still applies here. So it's quite easy when you remember that. It's quite easy to understand how your subnets will look like. So in this sense, magic number is really useful.
The only difference is now we have a lot more host addresses. We have 8, 16, 21 zeros for hosts, which means there's over 2 million hosts per subnet. For instance, if we take a look at this 10.192.0.0 subnet, the next subnet is 10.224. So that means that the host addresses go from 0.1 all the way up to 10.223.255.254 as the last usable host, and 255 is the broadcast. The next address is 10.224.0.0, which is the next subnet. All of these subnets are now /11. What about a more difficult scenario? In this scenario, we need to create over 300 equal-sized subnets of 20,000 hosts each, starting from the 10.0.0/8 network. So we need to create a lot more subnets, and we need a lot of hosts. Looking at this situation, we know that we're going to need to borrow bits from the host portion of our subnet mask. The question is, how many bits will we borrow? If we borrow 1 bit, we have 2 subnets. Now we have 4 subnets, 8 subnets, 16, 32, 64, 128, 256, 512. If we borrow 9 bits, we'll have 512 subnets.
So the initial task was to create 300 subnets. That's why he had to borrow 9. Yeah, he couldn't stop at 8, which would give him 256 subnets, which would the number wouldn't be enough because the task is to create 300 subnets. So he had to borrow 1 more, which will allow to have 512, which will satisfy the initial conditions, right? Here we are.
that we create, and that will be sufficient to meet the demand for 300 equal-sized subnets. What about the requirement of 20,000 hosts each? We have 15 zeros left for hosts per subnet. 2 to the 15th power is 32,768 minus 2 would be 32,766 hosts per subnet. That meets the requirement of having at least 20,000 hosts in each subnet. So this scenario would work. You can see here that I've now highlighted the borrowed bits from the subnet mask. I've also converted it to decimal here, 255.255.128.0. And I've already ascertained that the last 1 in the subnet mask is in the 128's place, so the magic number is 128. The subnets will still go up by 128, but they'll also need to go up for every number possible in the second octet. If we look below here, we can see our subnets. The first subnet will be the 10.0.0.0/17 subnet, then the 0.128 subnet, then the 1.0 subnet, then the 1.128 subnet. And as you can see, we're iterating through every possible number in the second octet and then going up by 128 in the third octet. If I was to list out every possible subnet, we'd go all the way up to 10.255.0.0, and the next subnet would be 10.255.128.0/17 is our last subnet, for a total of 512 subnets. In a situation like this, there's many more subnets and many more hosts per subnet, but the rule of the magic number still applies.
This is a bit less obvious kind of case, a bit more difficult. But yeah, but to understand that you increment by 128 in the third octet, it kind of applies. Yeah, so so you add 128 to in the third octet, and then you add it again, and then you need to increment the second octet. Yeah, because it comes to 256, and in the third one. So you kind of it spills. How can I? Yeah, I mean how I understand it, but yeah, how in my mind it works. So you kind of you have to the I can't yeah, but I can't even express it. I understand how it works in my mind, how I can see it. So you've got this subnet if you didn't borrow 17, if you borrow 16, so you just would go by one here, right? So 0, then 1 in the second octet. So imagine that you just borrowed 16 instead of 17, like in this example. So that increment would go just 1 third, and then 2, 3, 4, 5, 6, 7 until 255, right? Well, beginning from 0 with 0, and but by moving to the right, you kind of splitting each one of those again in half. So 128 each. Yeah. So if you had 6/16, you would just increment in the second octet, and each 0, 1, 2, 3, and each one of those would have 256 addresses. If we just take into account the octet number 2, but if we borrow and move to the right, and now we borrow 17, then each of those kind of subnets you have to split in half, and they would each contain 128. If we disregard, if we don't count the last octet, so we're talking about third octet only, so that octet will be split into 128, and you have to and now you have to so you have 10 0 and 10 0 again, but with 128. So 10 0 0 0 100. I don't know if I explained it well. I don't know, probably not, but that's how I see it. I can't express it, sort of my mathematical calculations in my mind. It is, to be honest, it is a bit difficult mathematically, kind of to apply it. Maybe just, I don't know, maybe spend a bit more time on this. My advice, because it does take a bit of time to settle, to be honest. I can see it. Yeah, I don't know. I don't know if it helps, but maybe it's yeah. So when I imagine this, when I do this subnetting, I would think about 2 octets where this happens. So we're talking about octet number 2, number 3. So kind of disregarding the last one, and all the action will be going on in those 2 octets, because you increment in the second octet and also third octet, right? So that's where, because the last octet is always 0, the first one is always 10. So and you need to understand basically the kind of rule by incrementing by 128 instead of 256 if it was 16. I don't know if it helps. Just imagine, just remember that all of this is available to you as well. Yeah, so if you ever stuck, hopefully you won't. I mean, there's no need to subnet like that, to be honest. And none of this of your practicals will include anything similar to this. Most of the subnetting will be in the last octet, and sometimes in the third octet, which are a little bit easier.
Pavel,
Yeah.
just a quick question though. If you go back to the question, is that how they kind of be worded in the exam? Because if you go back to the previous slide where you asked the question to do
This?
no, the one before showing the question, where it should create, where is it? Go back. Yeah,
1,000, yeah.
yeah. It's
Yeah.
no, wasn't that one? It was not that one. The next, yeah. No, go again. Go again. Go again.
No, I think
Go
it
forward.
was. I think it was in video. You're talking about video. That was in video.
Play the video then. So
Yeah.
yeah, it's that's that question would have thrown me off because it's saying create over 300 equal sized subnets of 20,000 hosts each. And for me, that's quite specific. It's not saying create at least 300 with at least 300.
Well, it does. It's just different wording, but that's exactly what
Exactly.
it means.
I
At
know, but
least 300, yeah.
yeah, it's just the way they word it. For me, I was looking at them thinking that it wants me to create 20,000 hosts, not at least 20,000 or more, if that makes sense. I don't know if anyone else thought the same thing, but for me, that's kind of like it's just the way
Well,
they ask the
yeah.
questions makes me confused about what they want.
Well, they want
Just me.
300 each, and if you calculate which one satisfies here, so how many? Basically, the question is: you given 10,000/8. This is your starting point, and how many bits you need to move to the right to create enough subnets. So if you move 5, you've got 2 to the power of 5, which is 32, isn't it? Subnets. If you move one more, 64, then 128, then 256, not enough, right? So 8 is not enough. So you need to borrow one more, and then you every time you move one to the right, you double up. Yeah. So then 256. If you borrow one more, which will be total number is 17. Subnet mask will be 17/17. Then you can create 512, which will satisfy these requirements. So 300, yes. You're creating 512, you will have extra unused subnets, but this will satisfy your requirement. If you borrow just 8 here, then you will have only 256, which is not enough. Yeah. So 300. That's basically what it means. They're not really tricky questions. Yeah. Well, I think it means the same. I mean, over 300, it means 300 or more, right? That's what it means. I don't know. I mean, wording maybe I mean, but you're talking about some lexicology. I don't know. It doesn't matter. Come on.
No,
It doesn't
no,
matter. I mean, the meaning is 300 or more. That's what it is.
yeah, I hate. Oh gosh, it's one of those confusing ones. It's just, I think it's how we read. I mean, that's the problem. Each one of us gonna have. We're gonna see the question and read it differently based on what it is. I think Frank had the same sort of issue with something the other week when we first started about what it was asking us to do, and I read it differently than what he read it, which my way was right at the time. But in this way, it's just confusing about what they exactly want, rather than yeah. Anyway, just move on. I just have to.
I think you're
So,
just trying
so
too
to be
hard.
safe,
You're looking for second meanings or something. No, it's very direct. I mean, 300 subnets. That's all. How differently can you read it? What else can it does it? What alternative meaning there could be? What could it mean differently? I don't know. It's a 300 equal sized networks. That's all. That's what it is. 300, at least 300 subnets. So you need to pick a number. So 256 is not enough. 512 is over, which will satisfy the requirement. That's all. That's what you need to find.
so basically, as long as we create, if they specify the value like with this, as long as we go over that value, if it's
Yeah.
if the value below it is too low, then just going
Yeah.
over it,
So
like
yeah.
it's all
So
right.
if you have 256 subnets, obviously it's not going to work
Right.
because
Yeah.
your number of subnets has to be 300 at least. So, but I mean, it's quite straightforward. I think. I don't know.
They could have
Maybe
just
if you
added that word, that
start
deep.
looking for second meanings or something, yeah, maybe. But it's quite direct. This. I mean, once you do it a few times, you will understand it will settle. Just maybe because it's just new and you just think about different things, and that's why it sounds a bit daunting. There is a lab. Okay, let's try and do this. This is just calculations, isn't it? So this is it. So what is? Oh, am I not sharing? Sorry. Why not? I was going to share, but I didn't. Yeah, there you go. Right. Okay, so the ability to work with IP version 4 subnets and determine network and host information based on a given IP address and subnet mask is critical to understanding how IP version 4 networks operate. Yeah, this subnetting, you need to understand it. Yeah, it's really important. And there is going to be quite a few questions in your exam, most likely. All this subnetting, splitting into subnets. Yeah, you will see a few questions normally. The first part is designed to reinforce how to compute network IP address information from a given IP address and subnet mask. When given an IP address and subnet mask, you will be able to determine other information about the subnet. So you need one PC with internet access. And by the way, all this, subnet mask calculator, subnet calculator, there are plenty of those. Yeah, so if you ever stuck in real life, you can always click here and do whatever, input the numbers, and it will calculate for you. All of this is available, and there are multiple instances of that. Look how visual subnet calculator. How visual? Yeah. Nana wants IP version 6 to take over. That one is a bit more visually kind of a bit less appealing than IP version 4. But in essence, IP version 6 subnetting is very easy. Yeah, so once you understand the principle, IP version 6 is much easier than this. Because the subnetting is built into IP version 6. It was created with subnetting in mind. So subnetting in IP version 6 is much easier. It's just the numbers don't look as simple as these numbers, but the principle is much easier. Anyway, let's do this. Problem one. We've got this IP address, host. Yeah, so we're looking at some computer device which has this IP address, and this IP address has this original subnet mask, and there is a new subnet mask. Sorry, let me read it again. What do they want from us? So yes, so this is the host device with this subnet mask. Why do we need a new subnet mask? Okay, whatever. So this is a new subnet mask. So we're splitting. So we need to understand to what network this device belongs with this subnet mask, right? So how do we this is usually easy because we no, I can't write here. I can if I do this. Right. So what is the network address? Look at this. Ignore the new subnet mask. So what is the network address here? Any ideas?
0.0.
.0, yes. Thank you. Yeah, don't forget 0. Yeah. Yeah. This is the network address, right? And now we need to split it into 224. 224 is how many bits we need to borrow? 3 bits. Yeah? Yeah. So 3 bits, which means we're creating 2 to the power of 3, 8 subnets. And how many bits we will have for hosts? We will have 5, right? Yeah. So 2 to the power of 5 gives us 32 minus 2, right? So we can see that, yeah, well, this is the magic number. You could, yeah, basically our increment is 32. So, and now we need to, yeah.
Maybe I just got lucky at working it out, but I kind of just did I just kind of, to get that 32, I just did 256 minus 224. Is that a lucky chance I got 32, like what you did, or is that another way of doing it?
256 minus 32,
No,
224.
I did 256 minus 224, and I got the
Yeah.
32. Is that another way of doing it, or was I just coincident I got that number?
No, it is, yeah, it is, yeah, it does work, yeah. You can do it this way, yeah, I guess, yeah, it is, yeah. Yeah, it does work, because if you do 226, 240, yeah, it does work. This is your increment. And right, 32, right? So basically, so 0 we're going to begin with, right? So that's where we, and then the next one will be 32, right? This is our increment. Then 64, then 96, 128 plus 32 gives us 160, and we have 139, isn't it? Correct. So number of subnet bits 3, number of subnets created 8, number of host bits per subnet is number of bits 5, yeah, because we borrow 3 for subnet bits, and then 5 we're going to be left for hosts. Number of hosts per subnet is 30, 32 minus 2. Network address of this subnet. So I suppose we need to, so to which out of this newly created subnets this host will belong to now? Yeah. So we've got, well, we can continue this, and we plus 32 will give us 192, and so on, 224, right? And that's it. So it's 8, right? So I've got 1, 2, 3, 4, 5, 6, 7, 8 subnets. So to which out of these 8, oops, what did I do? 8 subnets.
Is it 1?
It will belong to. Sorry?
Would it be 192.168.200.1?
No, it will belong to this subnet, no?
Oh yeah, because
If,
that fits inside.
yeah, 139 is between 128 and 160, right? Yeah?
Hmm.
So, yeah, it's network of the NEC subnet number 6. Yeah. And 128 is a network address of subnet number 5. So 139 will belong to this subnet. So which is 192.168.200.128. So this is the network address of the subnet to which that device host will belong to now. So what is the first host on this subnet? Address is 192.
128.129.
Yeah, 129. And the last will be
191.
159.
Oh yeah.
Oh, sorry, 158.
Oh yeah, because the next one is 160, so it take 2 off.
And broadcast will be 159.
Hmm.
Yeah? Just before 160, because 160 is the beginning of the next subnet. Yeah, everyone? What do you mean?
I'll give you a triple wow there because my head and my top lip is hurting me.
Well, I mean, what did we do? It was quite simple. We just understood what 139s of this. Oops. So the algorithm, we had this with this subnet mask, and for some reason, the subnet mask had to change from this to that, right? So we need to now to understand to which of the newly created subnets. So we're creating, so by changing the subnet mask, we splitting the existing /24. So this is /24. Well, we know this, yeah? And this one is /27. Yeah, we need to borrow 3 more bits. So we're moving the subnet mask to the right, increasing the size of subnet mask to 27 bits. And now we splitting the existing /24, the initial subnet /24 into 8 subnets, 32 IP addresses in each, 30 usable addresses, right? And so now we need to understand to which out of this newly created subnets this guy will belong to. Where does it fall now? So it will fall here somewhere, right? So this is the network address. So this is address of the next subnet. So so the broadcast is just one before 160, which is this. 128 is the network address. This guy, yeah, and then first usable, and this is last usable. That's it. It's not that difficult. Once you just understand what you're doing, it's not that difficult. And let's have a look at the last problem number 2. Well, this one will be such pain. Okay, so the next one will be exactly what we looked at the video, it looks like. Yeah. So we are given what? We given /8, this one. And now this it becomes /17. Remember the video? /17? Same story. So now we need to understand what is the network address of this. Well, it's kind of easy, yeah. So the network address that was that, right? Sorry, what am I saying? Yeah, it is. Yeah. Yeah. So yeah, it is. Sorry, I thought I was going mad. So the network is this, right? To begin with. And now we're moving it to 17, increasing it to 17. So we're creating what? Remember the video. So now the subnets will look like this: 10.0. What was that? 128, wasn't it? Yeah, 128, 0, and this will be the first subnet we create. Then 10, 1, 0, 0. Remember? Then it will be 128.0. Oops. 2, 0, 0. Yeah? Is it remember from the video? The magic number is 128, yes. Yeah. So so number of subnet bits. So we're going to increase it from 8 to 17, right? So I guess that's what it means, 17. How many subnets we're going to create? So from 8 to 17, we're borrowing 9 bits. So 9 means that we are creating 2 to the power of 9, 512 subnets. So initial was this, yeah, guys. This was the initial subnet mask. Hate this. Why they? Okay. Blah blah blah. So and that was /8, and then we increasing this to this. Zeros, right? From 8 to 17. This is 17. Yeah, this is 17. So from 8 to 17, we borrow 9. 8 plus the second octet plus 9 from the third octet. So 9 bits we borrow. So we're creating 512 subnets. Number of host bits per subnet. So how many hosts will be? So now we need to calculate this number, which is 8 plus 7, 15, right? Number of hosts per subnet. So this will be 2 to the power of 15. So last time we calculated, so it will be 32,000, 32, sorry, 3768. There you go. Network address of this subnet. Well, this is difficult, or not. Going by this, yeah. So 10.0.128, then next 10.1.0.0, then next subnet 10.1.128, 10.2.0.0. So to which, looking at this pattern, to which one this will belong? So so there are so basically each of the numbers will so 10 101. Sorry, let me just write it on the correct line. So 10 101 00 will be there, right? And the next subnet will be 10 101 128. Correct? And then will be, and then after that, next will be 10 102 00. And then 10 102 128. Yeah? Guys? So you can you see the pattern here? 10. So each second octet will be split twice. Yeah, will be split in half, kind of. So it will have it will in if you continue this pattern, this will be 128.0. Then how can I? Sorry, let me just change this. Oh, enhanced ink shapes. That's what it is. So 10 3, next one, 10 3 128.0, 10 4 0 0, and then 10 4 128. Yeah, and then you can continue. So basically each number within the second octet will be used twice with 0 0 and 128 0, and then you have to move to the next. So 4 becomes 5 twice again. So 101 will be used twice. Yeah, so with 0 0 and 128 0. So now we know 101 how it is going to look like. So we need to place this host address within one of those networks. So does it belong to 101.0.0 or 101.128.0? Yeah. So we've got what? 10 101.0.0 or 101 10 101 128.0. To which one of this this particular address belongs to? Yeah, it will fall. So it can't be 128 because 99 is a smaller number than 128. So it will fall. It will belong. So this will be the network address, right? 10 101.0.0. Correct? I think Nana is the only one who follows. You're the only one. No? No, it is. So this is the network address, yeah? To which this host 10 101.99.228 belongs to. Yeah, so within this so this network address, some reason my pointer disappeared and I can't see where I'm writing. So 10 101 can't write 101.0.0 is the network address. So this network will the range, yeah, the range. Range will be from because next subnet will begin at 10 101 128. So so it will be, sorry. What is the range? Range.
101.128. 101,
128.
127.
127.
Yeah.
I think that, yeah, I think this is and 255, yeah?
255, yeah.
Yeah, everyone. So this is the range, yeah, within this network. So we have, well, plenty of addresses. 32,000, isn't it?
254, right? If you leave the broadcast range away. I don't know. Is it?
Yeah, but this is the broadcast address.
Oh, yeah,
I mean,
broadcast range. Yeah,
so
yeah.
I'm trying to establish the range, and
Yeah,
now
yeah.
we need to. So this will be the network address, the first
Yeah,
one.
including the got it.
The last one will be the broadcast address 255. So the first usable will be 10.101.0.1, and the last usable, last host will be 10.101.127.254. Yeah. Everybody.
Yeah.
Thank you. This one is a bit tricky, to be honest. It's a bit tricky. It's only because we watched this video, it kind of fresh in my mind, but otherwise I would struggle myself, to be honest. It's just this calculations a bit they're not that straightforward. But the principle remains the same. So you need to understand what is the range, to which what is the network entire range within that subnet, and then you kind of you will see what is the network address, what is the broadcast, which one's first usable, which one's last usable. So now this is your host, and this is your original subnet. So you've got /16, isn't it, to begin with? And now you need to change to 224. So 224 is you borrowing 3 more bits, right? 224, yeah. 128, 192, 224, 3 more bits. So this becomes 1/19 subnet mask. And now we need to understand. So because you borrowing 3 more bits, you're creating. So this is subnet bits. How many subnets you're going to create? You need to tell me how many subnets you're creating by borrowing 3 bits. No? Is it familiar? So you're creating 8 subnets. Okay, let me just, so initial subnet looks like this: 4, 5, 6, 7, 8. 4, 1, 2, 3, 4, 5, 6, 7, 8, right? And then you've got 8 zeros, 8 zeros. So you begin with 6/16, this, and you move and subnet mask, you move it to the right and you borrow 3 more bits. So if you translate 2 to 4, you will get 1, 2, 3, right? This is your new subnet mask. So you're borrowing 3 bits. So number of subnet bits is 3, number of subnets created is 8, number of host bits per subnet. How many hosts you've got now? You've got this many. Why is it? This is Teams for you. It still enhances my shapes. So 8 plus 5 gives you 13, right? Number of host bits. Number of hosts per subnet will be 2 to the power of 13, which is 296, yeah, 2096, I believe. No, this is wrong. Sorry, 10 to 1024 is 10. So yeah, 8192, sorry, yeah. 8192, yes. So what is the network address of this subnet? So this guy now belongs to another subnet. So your increment is what is your magic number? 32. So you begin with 32.0, right? This was your original subnet mask, subnet network address. So you begin with this 172.22.32.0, and then you increment it by 32, right? So you can see already straight away that it will fall. It will not change. The network address will not change. Yeah, it will still belong to the same subnet. So it's the same network. Even though now the subnet mask is different. Yeah, before it was subnet mask /20/16. No, what did I do? No. Sorry, 32 will be not here. Sorry, yeah, that was wrong. That was wrong of me. Yeah, I'm sorry. I'm just so 32. 0 was the original one, but increment now. Increment goes by 32 in the in here, right? Sorry. So yeah. So 32, then 64.0, right? I think this is it. This is correct one, and then 96.0 and 128.0. Yeah, or not? Correct. Then 128. This is yeah, and so on. So this will belong to this will belong to this subnet. So network address of this subnet is 172.22.32.0. And before it belonged to, so the original network address was, so to which network this belonged to before, when it had /16. So the original subnet was 172.22.0.0, isn't it? Yeah? /16. Yeah, and this one is /19 now. Correct? I think it is correct. No. Well, you can do your go and put it into your subnet mask calculator here if you're in doubt, and it will show you. Yeah. And then there is more. Problem number 4, problem number 5. Oh. Okay, let's do this. Problem number 4. So host belongs to this subnet, right? This is /24 at this moment. Sorry. Well, this is the host address, yes, to the network /24, yeah, subnet mask. And now we need to increase it to /30. So instead of /24, we increasing it, and it will become /30 now. So number of subnet bits. And so why /30? Well, it's here, from here. from here, right? If we convert it, so 252 is 6 bits, right? So originally it was 24 bits. Now I'm going to only so originally /24 means 8 bits in the last octet number 4, and now we are going to do 252. 252 looks like this: 1 1 1 1 1 1 0 0 /30. Correct? So number of subnet bits, we borrowing 6. How many subnets we're going to create? 2 to the power of 6 will be 64. Hosts bits per subnet will be 2. Yeah, so 4 minus 2. Number of hosts per, sorry, no. What am I saying? Host bits per subnet, yes, 2. Yeah, it is number, yeah, 2 host bits. And hosts per subnet is also 2. Yeah, because it's 2 to the power of 4. And we need to exclude 2, and you get your 2 number. Yeah, /30 subnet gives you 2 usable hosts. Number of hosts per subnet is 2. Network address of this subnet. Well, okay. So what is the network address of that subnet? So your increment will be 4. Correct? So you can try to divide 245 by 4 and see what is the it won't divide. So 240 divided by 4 will give you 60. So 61. Yeah, it looks like. Yeah. So 61. Sorry. What? No, it's not 61. 244. Yes, 244. Sorry. Yeah, 244. What am I doing? Yeah, 244. That's what I was going to say. So network address of this subnet will be 192.168 1 and 244. If you increment by 4 from 0, and 4 plus 4 plus 4 plus 4, so you will come to 240 and then 244. And next one will be 248. So this is your range up to 247. So this is your subnet from 244 to 247. So network address is 244. First usable is .245. Last usable is 246. And broadcast is 247. Is it understood, guys? So, or not? You increment by 4, magic number. This is your incrementation coming, well, so 245 falls within a network which begins with 244 network address. And because increment is 4, so it will end with 247. 245 falls within that subnet, yeah, between 244 and 247. No? Anybody? Any feedback? Silence. Huh? How is it confused? Okay, let me try it from beginning. Okay, let me try from the beginning. Look, so we've got 245. This is /24 subnet. Is it correct? Everyone agree? Yeah, /24.
Yeah.
Right. So at this moment, network address is 192.168 and
0 0 1 0
10.
Yeah.
Yeah, /24. So this is the network address. Okay. Now we need to create subnets with this subnet mask. So what is this subnet mask? 252. What is this subnet mask? convert it into bits. How many bits? Okay, so 8, 8, 8, 8. Maybe one more. One too many. And so 252. Convert it into bits for me. How many bits do I need to? True. You can subtract. Yeah, 255 minus 252 gives you 3. So the last 2 will be zeros. So you need to. So 255 will be missing 2 bits, 2 last bits. So 2 last ones will be zeros. The rest will be ones. Yeah, or not? Or you can sum up all these 6 bits if you like. 128 plus 64 plus 32 plus 16 plus 8 plus 4 will give you 252. So this address is the same as this, but without last 2. If you exclude 2 last ones, which are 1 and 2, yeah, which give me 3. Everyone confused still? Better, right? So this is what is our new subnet mask looks like if we convert 252 into bits. And so now we know this is /30 new subnet mask. Yeah, we need to move from here to /30, creating more subnets from initial /24 network that we've got. So how many bits we need to borrow from 24 to 30? How many bits we're going to use for subnets? From 24 to 30, how many bits we're borrowing? 6. This is a tricky question, right? And how many subnets we are creating?
Two over 6.
How many?
64.
64. Yeah. Number of host bits per subnet. How many host bits here? How many host bits? 2.
62.
2, right?
Yeah.
So how many hosts this will allow us to have in each of those 64 subnets? How many hosts?
62.
2 minus 2. 2 to the power of 2 minus 2, which gives us 2.
Yeah.
All right. So I guess this is quite easy. The confusing part is now to understand to which network newly created subnet this address will now belong to. 245. So remember, we need to increment by 4. Yeah, so we begin with 0. So 255, 255, 255.0. Sorry, not 255. Sorry, 192.168.1.0. This is the network address. Yeah, and then the next subnet will be 192.168.1.4. And then 192.168.1.8.1.12.1.16. And then eventually we will come to 240 because you can divide 240 by 4. And then next will be 244. Yeah? So 245 will apparently belong to a network which begins with, which looks like this: 192.168.1.244. Yeah. So this subnet will begin with 244 and will end up with 247. 4 addresses, yeah? 4 addresses belong to this subnet. One will be reserved for network address, which is 244. 247 will be broadcast address, and you've got two usable. First, 245, and last one will be 246. You've got only 2 which you can use. We know this. This is the 2 addresses only we can have in any of those 64 subnets. So 245 will now belong to the network address, to new subnet with network address 192.168.1.244. Now, Arvil, are you still confused?
Yes, I totally am. I'm getting quite annoyed actually. I think I may have to talk to you after because I can't get my head around it. I'm getting it and then I'm not getting it and I'm totally confused. So,
No,
move on. Carry on. I'll find a
No,
way.
look, wait. What do you mean carry on? Look, so you've got,
I mean, Pavel, I'm happy to talk to you afterwards. I don't want to hold up the class. I just need to get a basic understanding of it. It's just me. Yeah. So, we could, if you got time
no,
afterwards.
look, let me show you. So initially, yeah, we had a /24 subnet, which belonged, basically contained all the host addresses within the last octet. Is it clear? Are you following?
Yes, that is clear. Yeah.
Yeah, so we've got
That's-
anything, so everything from 0 to 255 belong to the same subnet,
Mhm.
all the addresses, right?
Yeah.
So 256 altogether.
Mhm.
Now, we, by moving the subnet mask, we increase the subnet mask. Now we're splitting these 256 addresses into 64 bits, into 64 parts. So 256, we dividing by 64, which will have 4 addresses in each. Is it
Mhm.
clear?
Yeah.
Yeah, so 60, so we're splitting one big 256 large subnet into 64 smaller ones. And how small they will be? There will be 4 addresses in each. So 0 to 3 will belong to one subnet now. Then from 4 to 7, you have another subnet. From 8 to 11, you have another subnet. Correct?
Mhm.
So, and then we will come to 240 to 243 will be another subnet. And 244 to 247 will be another subnet. Correct? So 4 each. 4, every 4, yeah, and 64 of those. So this guy will belong now to this one. It falls between 244 and 247.
Mhm.
That's it. And this is the network address. We use this first number within this 4 to identify entire subnet, entire this range, entire piece, kind of, I don't know, entire well, subnet. I don't know how to describe it. So 192, 168, 1 and 244 is the network address with the new subnet mask of 30. Yeah, so this device, one host, this host now belongs to this subnet. In that subnet, 245 is the first usable, 246 is last usable, there are only 2, 247 is broadcast address, 244 is network address. That's all. All 4 all 4 addresses we identified. So network address, first usable is 245. Last usable 246. Broadcast is 247. That's it. It's not about even maths. It's about kind of understanding what you're trying to achieve. You're splitting something into smaller parts. This is what subnetting does. You have the original network, and you just split it into equal parts normally. Yeah. Well, at this stage, that's what we're going to do. We're going to split into equal parts. This one is well, a little bit more difficult because we begin with /16. This is /16, remember? Yeah. And now we need to move to /24. Yeah. So the new one will be 24. So how many subnet bits we have now?
8.
8. Yeah. Number of subnets created.
Is that 2 to the power of 8? Yeah.
Yeah. Yeah.
Is that 16?
2 to the power of 8 will be
Oh, no,
256.
Yeah, sorry.
Number of host bits per subnet. So this was we originally had 16. Now we've got only 8. Yeah, 8 bits. So now how many hosts per subnet?
Two, 5, 4.
Yeah, hosts. What is the IP address of this subnet? Network address of this subnet. Sorry, network address, not IP, network address.
10700. Yeah. 0, 0.
Yeah. Yeah, so 555 falls within the first subnet we're creating, right? So the subnets we're creating, the addresses will be 128.107.0.0. Then the next one will be 128.107.1.0. Yeah. And then next subnet will be 128.107.2.0, 128.107.3.0. So this is until we reach 255. So we're creating 256 subnets. We're using second octet, remember? Yeah, we moved from 16 to 24. So 128.107.0.0 is the first one. 128.107.1.0 is the next one. 128.107.2.0 is the another one. And then until we exhaust this third octet, and we come to 128.107.255.0. This will be our last out of this 256 newly created subnets, right? So we're creating 256, beginning with 0, so 0, 1, 2, 3, and each one of them will be, so the range within the first one, 128.107, so 128.107.0.0, and the last address here will be 128.107.0.255, right? This is the range, 256 altogether. This will be the network address. This will be the broadcast address. And .1 within there will be the first usable, and .254 will be the last usable, last host address. And, well, broadcast will be 255. Yeah? What's so this is really simple, no? this date has been finalized at 10th of April. Can we have it moved to the Patricia? Is it? Yeah. I didn't. Is it? It is final. It is finalized. I mean, if you miss it, you're welcome to come and maybe do it in person if you like. Again, on maybe next week. I'm just
Would
reading
be
the
lovely,
questions.
but I just cannot find anyone who could help me with my children that day. So if I could come any other day, is not the problem. It's just I'm trying to anyone to help me out, but I don't have a chance.
I understand.
To come over on 10th, yeah. So 10th, just because it's the last day of the half term, and yeah.
Yeah, I got it.
I know not everybody on the same boat. I was just thinking if this is finalized because I think I missed that.
Maybe in this case, you know what? I didn't realize it was school holiday. It's half term. Maybe we can actually move it to 17th in this case. Yeah,
that would be beautiful.
Yeah, thanks. We can actually, let's move it to 17th in this case because it will be a problem for many of you. I need this dumped down way more for me. I'm a little confused now. Sorry. Yes, I missed this question. I think I think it will be probably better if we move it to the next Friday after that, which is 17th. Yeah, so everyone is. Yeah, I didn't realize. Sorry, because I don't follow the school holidays. So yeah, I kind of. Everyone will. Yeah, everyone will support it, I guess. So in this case, yeah, let's move it to 17th. It's not a big deal. We can still. Yeah, it's not like we have to do it on the 10th. It was something I was planning, but yeah, we can do it on the 17th, and you will have more.
Perfect. Thank you.
Yeah, you will have probably more stuff. You will probably have better understanding of everything.
And what time is expected us to be in a center from 9:30 to 3, or just for me to plan the travel?
Yeah.
Okay.
9:30. Same.
Okay. And it's the Selby Center, yeah?
Selby Center, yes.
Okay. Perfect. Okay.
All right. Well, thanks for pointing this out. All right. Yeah. So we can move it. It's not a problem. Right. What else? I think we've done enough here. It looks like. I think maybe there's another problem. So here it's quite. I mean, this one is quite simple, I guess. Again, we begin with /24, which is quite common. And what is this? I mean, I'll let you do this. Okay, yeah, because I know how to do it. You tell me, what is the new subnet mask? How many bits there will be in the new subnet mask? You can put it in the chat. You can voice it out. Come on, go on.
Is it 8 bits?
What do you mean 8? 8 altogether. So we begin with 24. So what will be the new one? Okay, so look, if we represent this, right? 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, and all zeros. This is where we begin. Yeah, and now we need to extend it. We make it. We want to make it 248. So how many bits here out of this 8 we need to borrow? We need to extend this in this direction, but how many bits? 248. So you can, as I mentioned before, look, 255 minus 248 equals 7. So how many bits will have to remain zeros so in here, yeah, we're looking just here. So how many bits here will have to be zeros? How many bits will need to be ones to represent this number 248? Convert it into binary.
I think you have to use 1, 2, 3, 4, 5 bits.
Five bits. Five.
Five.
Yeah.
Thank you very much. So new one will be like that. Yeah. So 5 plus existing 24. So the new subnet mask will be 29. Yeah.
Okay.
So how many subnet bits? That is 5. Or you can say 29 if you want to go this route. I mean, or 5. We'll borrow 5. Yeah, we'll move it to 5 to the right. Number of subnets created. How many how many new subnets? Remember, we begin here with 256, and now we need addresses, and then we split that into how many subnets?
Would that be 2 to the power of 5, right? Or
Yeah,
32.
32 subnets. So we're splitting 256 original addresses into 32 subnets. Yes. So how many host bits per subnet and how many hosts per that subnet? Okay, host bits. How many host bits here? 3. And how many? So three host bits will allow us how many hosts? 6. Yeah. So 8 addresses host, but the number is how many hosts? So 6 hosts. 8 IP addresses, yes, but 2 of them will be reserved. And now this is the tricky question which everyone doesn't like. Everyone gets confused here. So now we need to establish to which of those newly created 32 subnets this host will belong now. So the increment will be what? 32. So you begin with 0, then you've got 32, you've got 64, 96, 128, 160, 192.
Yeah.
So it looks like 180 will fall somewhere in between here, right? Between 160 and 192. Correct? So 180 will belong to the network which has this IP address. This address. So the network address is 192, 135, 250, 160. What is the broadcast address of this? Why? So what is the last address within this?
192?
191.
1. Oh, the next host.
It's the beginning of the next network, of the next subnet. So 191. So 161 is the first usable, and 190 is the last usable. And anything in between. So 161, 162, you can use 168, 180, you can use 190, 189, and the last one will be 190. That's it. So 30 addresses you've got. Sorry. What am I doing?
Why is that 32? Why is that 32?
Sorry, yes,
32.
my
It's supposed to be
mistake.
4.
Totally wrong. Everything
Yeah,
is
it's supposed to
wrong
be 4.
because I thought it was
04.
32, and then you played with me, and because this increment is 8. Yeah, so increment is 8. Who said? Sorry. 8 here, yeah? So the magic number is 8. And we calculated everything wrongly. Wrong. Sorry. Yeah, so we begin with 0, and we increment by 8. And that will be different. Yes, so 180 divided by 8. How many 8s will fit within this number? I think it's 176. 176, yeah? Then next one will be 184 and then 192. I think it's 176. Sorry. Totally I think I added to the confusion even more. So yeah, now we're doing it right way. So 176 will be your network address. Yeah, anyone? Any objections to this?
160 plus 128, 168.
So is it divisible by 8, 176? It is, right? So increment is by 8, and you need to understand, you need to divide it by 8. So it will be 22 8s. Yes, so 22 times 8 gives you 176. Well, it doesn't matter how many times, but as long as you can divide this number by 8. That's so you go. Every number will have to be divided by will have to be divisible by 8. So 0, 8, 16, 24, 32, 40, 48, 56, 64, and so on until you reach 176. So this is what we are looking for, because our device is 180, isn't it? So it has to belong to this network, 176. Plus 8 is 184. So sorry, someone is talking. So 184 is the next subnet address, and so the last within this range is 183, isn't it? Yeah, 8 numbers per subnet. Each of those 32 subnets will have 8 IP addresses. So beginning with 176, the last within this range will be 183 within this subnet. So this is the broadcast address. So first usable will be 177, one after 176, and last usable just one before 183, which is 182. Okay. So to understand to which subnet it belongs to, we know that increment is 8, so we need to divide this by 8 and see how many times it can fit. What is this? When you divide something by a number and there is a remainder and something which is just before the remainder, I forgot the English, sorry, name for it. So 176 will allow us to divide by 8 with divide by 8 without remainder, right? So that is 22. So 176 is the address to which 180 will belong to, network address. It will fall within 176 to 183 range. I don't know. Anyone questions, or we can move on? I think we have to move on. Yeah, there is time for the break. Yeah, definitely. Okay, let's take a break, 10 minutes. So 11:25 exactly. So 10 minutes from now, 11:35, shall we? Yeah, 10 minutes.
En Haïti, mais toute ma famille vit là-bas. Je sais que notre pays traverse des situations extrêmement graves avec les crises politiques, économiques, sanitaires. Donc, bon, Van qui avait choisi de admissions now.
If you have an itch à 60 ou 70 ans, les hommes ne désirent plus qu'une seule chose chez une femme. Et ce n'est ni la beauté, ni la jeunesse, ni même la perfection que la société aime vendre. Arrivés à cet âge, les hommes ont déjà traversé les tempêtes. Ils ont aimé, perdu, construit, parfois échoué. Ils ont vu ce que le temps efface et ce que le temps révèle. Alors,
Yeah, I think we should. So let me just clear this and hello, are you here, guys? Yeah, can you hear me? Microphone is on. Yeah, okay, okay. So
Yeah, I'm here, Pavel.
yeah. So if it helps, you can always think about it from a perspective of what you begin with, and then what you're going to end up with after splitting your initial network. So for instance, if you have an initial network /16, and so initially you've got this many bits for hosts, isn't it? So you've got 65 536, yeah, addresses, and then you borrow, you move one to the right, and you're splitting into two, and 2 times this number will always get you to, well, because you minus, you always minus 2, so this is actually 8, right? So if you multiply it by this by that, you will always come to your initial number of hosts or IP addresses. Yeah, so any way you split it, this number doesn't change. This is what you begin with. So if it helps, yeah. So sometimes maybe it can visualize it. So you've got this network with that many IP addresses, and then you split it in two. So 2 times 32,768 gives you this. 4 times 16,384 again gives you the same number. You've got your space, and you split it any way you want. So you've split it in 2 and 4 and 8 and 16, and then you can split it into 1024 by 64, right? So if you multiply 1024 by 64, you will come to 65,536. If it helps, yeah, maybe this can kind of, you can visualize. Yes, you've got this space range from 0 and up to 65,536, and then you split it in the middle. You've got 2 halves of 32,000 and a little bit each. Then you each of those halves you split in 2 again, so it is a quarter of original size. So you've got 4 bits, 4 parts of the original 65,536. And so on. So you can continue splitting into 8, into 16, 32. So every time you split, so yeah, so you've got this to begin with, then you split it in half. Then each half you split in 2. Then you split each one of those 4 quarters in half. You get 8 bits. Then you split into 16. You split each and every of those 8 parts in half. You've got 16 now. Obviously your range will shrink. So more subnets, more parts you've got. Each one of those, yeah. So you began with this is 665,536, and then when you split it in half, you got obviously half of that in each of the halves, which is 32,768. And then you split in half and in half and half. So, and every time your range will shrink. Number of subnets increases. Each subnet will have fewer numbers. Simple. But the sum, or not sum, but well, sum, yeah, sum of all these parts will always be the same, because you always this number doesn't change. You began with this, and it will stay the same. It's a constant. So it's just the division is different, and you need to calculate those divisions. So if your original host was here somewhere, right? So this is the address, and then you split it into that many parts. So it will be here somewhere. Now it will belong to this subnet, not to one large subnet like that. But now it sits somewhere in the middle of this subnet. Yeah, and you need to understand what is the network address of that subnet now. So this host, this single address, single IP, it will belong to one of those newly created subnets, and that's what we did in that lab in those calculations. Yeah? I don't know if it helps. If it helps. Right. So let's do subnet to meet requirements. Right. Why would we do this? Subnetting. So your enterprise network will have an intranet, so company's network, internal network, typically with private IP addresses. Yeah, so 10, 172.16, 198.168, 192.168. So private IP addresses, and some of the part of your enterprise network might have some services facing external customers, external people, yeah, so clients, customers, or maybe just partners, whoever. So so they need to be accessible via from internet. So this may be closed to anyone who's trying to reach your intranet, but this part needs to be open for public access. So this is called demilitarized zone, because this usually is kept separately from your intranet because of the security issues and so on. So, and also this will have to be accessible via public IP addresses. So these are private and these are public. So because private are not routable, they are not reachable. So the public, so it could be a server for whatever reason. Yeah, it could be a shop, whatever, some catalog, whatever, which should be accessible from outside. And so yeah, so company could use any of those private addresses. So for instance, 10/8, and then subnet it on 16 or 24 boundaries, whatever your design is. It's up to you how you divide your private network, your addressing scheme. This is up to you. The publicly accessible area, DMZ zone, will have to have public IP addresses. So those public IP addresses could be quite valuable if you have a bunch of addresses and you have to buy them. You have to pay for them. This could be the reason why you split those quite accurately and not accurately, but what's the word? Because of the you have to cherish them. You have to be they're not just expendable resources. Yeah, so you buy these addresses and you have to really look after them. Yeah, so you have to use them. Whereas private addresses, you can be a little bit more wasteful here. That's what I mean. But also, even private addresses, you will have to split them somehow, subnet those private addresses, and this could be your reasons for subnetting. Yeah, so even private addresses will have to be subnetted. So there are two considerations when planning subnets. So number of host addresses, how many hosts, or you might need to decide that you need some specific number of subnets. So efficient IP version 4 subnetting. So it has to be efficient. That's what I was looking for. Sorry, word. So you've got in this example, corporate headquarters has been allocated a public network address 172.16 by the ISP, and this gives you /22, and this you basically you bought it from ISP 1022 host addresses, and you have to how you use them need to be careful. There are 5 sites and therefore 5 internet connections. So this is your business needs, business requirements. You've got 5 sites, 5 separate sites within your network. And in 5 internet connections, which means the organization requires 10 subnets, with the largest subnet which requires 40 addresses. So we've got 30 here, 10. This is your business needs. Yeah, it could be different, but in this case, this is what it is. So 10, 25. And now you need to efficiently split your network. Yeah, so subnet. Like 10 subnets with /26 subnet mask. And that will be, yeah, that is your 10 subnets. So you've got subnet here, subnet there, right? Subnet here, subnet there. So 10 altogether, right? 1, 2, 3, 4, 5, 6, 7, 10. And this is your design here in this particular case. It's not very efficient, but it is efficient enough. Yeah. It could be even more efficient. This is we're going to look at with variable length subnet mask. But for now, all your subnet masks are the same length. So here we've got /26, right? This one. All 10 subnets do not are of the same size. They don't differ one from the other. So there's a packet tracer. Let's do this packet tracers, which will we will design an IP addressing scheme and then assign IP addresses to network devices according to what is required. So let me just share this screen. Yeah, packet tracer 1175. By the way, there are some activities here which you can play with. Determine the number of bits to borrow. How about this? So we can play for a bit, maybe 1 or 2. So you need, in this activity, you are given the number of hosts that are needed. So in this case, it's 250, isn't it? Yeah. And determine the subnet mask that would support the number of hosts as specified. Enter your answers in binary, decimal, and prefix notation format in the fields provided. Right. So with 250, you've got this, right? So this is your answer already. And with 25, so each subnet needs to have 25 hosts. So what will satisfy this requirement? What subnet mask will satisfy this requirement? We need a network with 25 hosts. Well, tell me how many in prefix notation. So how many hosts, how many ones in the subnet mask we need? So what is the prefix? / what? How many bits?
32. 32.
So you need a subnet mask which will accommodate 25 hosts, 25 IP addresses. So So 32, someone said 32. 32 is what? 32 is
8 subnet.
So it's subnet. So you need to subnet to a size which will allow 32 hosts, 32 IP addresses, right? Which is 30 hosts. Is this what you're trying to say?
Is it 3 bits you need?
So okay, if we borrow 3 bits, right? So this will be 27. Is that what you're saying?
Yeah.
So how many subnets we're creating? We're creating 8 subnets. Yeah? 2 times 2 to the power of 3, 8 subnets times 32 each, right? Is that what you're saying?
I hope so.
8 times 32 will be 256. Easy. So 8 subnets, 32 addresses in each.
Mm-hmm.
Will it satisfy this requirement? So we've got 32 addresses, which gives us 30 usable addresses. So will this be enough?
Yeah.
Is it suitable? Okay.
Yeah.
So this is what we're looking for, right? So in this case, so we need to say this. So did you say 3 bits? 1, 2, 3, right? And so what is this number?
Hold on. That would be I don't know if I'm doing this right anyway, but hold on. 1, 2, 8.
Okay, 4,000. So we begin with 24, right? Huh?
224. Oh, he did it already.
Yeah. To have a subnet which will accommodate 1,000 addresses. So what do we need to do? We need to actually move subnet mask to the left, right? Not to the right, to the left.
Mm-hmm.
So if we have a subnet mask /24, it allows us to have 254 addresses, right? Correct? If subnet mask 24 gives us 254 addresses. If we decrease it, if we move it to 23, then this will double. We will have 512 minus, sorry, what did I do? So 512 minus 2 will give us 510 addresses. This is not enough. So we need to move to the left again, 22, and this will allow us the address space for the hosts will increase to 10 bits now. Yeah. Six, 0, 0, 0, 0, 0, 0, 0, 0, 0, and 0. So 10 bits for hosts now. You understand? We've got 10 bits for hosts. 2 to the power of 10 will give us 1024 minus 2, which is 1022. So this will satisfy this requirement. We need to have at least 1,000. So this is good. This is what we're looking for. And the subnet mask will be here 255. So we move to 2. So this will be 252, isn't it? Oh, sorry, 0. What am I doing? Yeah. And this is 22, did I say?
Yeah.
And this is how it looks like. 6, 0, 0. Look, guys, you need to just remember, yeah, instead of you're starting from scratch every time. Look, there is a shortcut, yeah. To accommodate 1,000, you need how many bits for hosts? So you need 8 plus 10 plus 2, 10 altogether. 2 to the power of 10 gives you 1024. 75. Okay, to have 75 hosts per subnet, what should be the subnet mask? Here, this is where all the magic is going to happen. So if we leave it at /24, like in the first line, this will allow us
one and 7 zeros, right? So you borrow 1 bit there. Is that right?
1 and 7 zeros, yes. Will allow us to have 128. Yeah?
Yeah.
We cannot do more because this will decrease the size of the subnet to 62. So this will be too much. Yeah. So the splitting into 4 subnets, 62 each, that is not going to give us 75 addresses. So we have to keep it like this, which will allow us 126 addresses per each. This is what we're looking for. 255, 255, 255, and 128, isn't it? And this is /25. 10. 10.
That would be one,
Three.
one, one,
One, one, one.
one.
Zero, zero, zero,
No,
zero, zero,
hold
zero.
on. No, it'd be, is that right?
Okay,
zero,
3 ones.
look. How many bits we need to keep at 0 to allow us to have to accommodate 10 within that space? So how many zeros we need? Okay, don't count ones. How many zeros here? 2 to the power of 3 will give us 8. Not enough. 2 to the power of 4 will give us 16 minus 2, which is 14. This is what we're looking for.
Yeah.
Huh?
4.
2 zeros.
4.
Why 2? Who said 2 or 3? So it has to be 2 to the power of 4, which gives us 16 hosts per each, and minus 2, which will give us usable IP addresses. So 14 in each subnet. So zeros, we need 4. So 4 ones and 4 zeros.
Yeah.
This is what we're calculating. We're calculating this. How many hosts can we fit within the host bit? Here we've got 128. Here we've got 8 plus 2, we've got 1024. Here we've got 32. And here we've got 14. Yeah, 16 minus 2. This is what we're looking for. And so the subnet mask is prefix. I mean, so this will be 24 plus. Thank you very much. And this will look like 240, right? So now we need to accommodate 500. So if we use the entire last octet, it will still give us only 254. And we need 500. So we need to increase the host portion from 8 to 9, which will give us 510.
Yeah.
Yeah?
Yeah.
So we need 9 host portion, 9. So all zeros here, 7 zeros, and one nil. There you go. Two, 5. What is the subnet mask here? This. If you repeat. Thank you very much. And 20. So what's the number? Let's check. Yes. All right. If you are not sure, you can just say show me. It will show you. If you don't know. So here, yeah. So you need to accommodate hosts, and you need to understand how many zeros. What is your host space? This is your host space. So you increase it or you decrease it. How many is enough? How many zeros is enough? How many bits to accommodate your host is enough? 5 zeros give you 30. 10 give you 1022. 1024 minus 2. This will give you 126. This will give you 14. 16 minus 2. This will give you 512 minus 2, 510. Yeah? Right, let's move on. I hope it will be okay. So, where is this subnet to, packet tracer? Subnetting scenario. Okay, what is let's do this. Don't worry, this subject is always difficult. Every class will have nobody does maths anymore, so it's quite difficult to get your head around it. But you'll get used to it. Just a little bit of practice. Right. So here, well, this one is easy from what I can see. Let's see. So we need to design.
Can you clear the board, Pavel?
Huh?
Can you clear the board? You need those numbers on top of the board because I can't see the writing underneath.
So design an IP addressing scheme and then assign IP addresses. So design is something new, which we've been doing today and last session, but assigning is something from before, right? So this will be expected of you to know this, right? So in this activity, you are given the network address like that. So /24, this is important. Yes, so your subnet mask is /24. So you've got network which well, standard last octet is given to hosts at this stage, and now you need to subnet it, and each LAN in the network requires at least 25 addresses. At least 25. So we know that we need to split it somehow. And 25 addresses, the switch and the router. So 27, yeah, altogether. The connection between R1 and R2 will require an IP address for each end of the link. So between these two, you need only 2 addresses. So 27 per each of those 4 subnets. So design an IP addressing scheme. Subnet this network into the appropriate number of subnets. Based on the topology, how many subnets are needed? Well, 5. You've got 4 plus the one between 2 routers. So you need to have 5. How many bits must be borrowed to support the number of subnets in the topology table? Well, if you have 25 at least, plus 2 for router 27 and the switch, so 27. So you need to do what? What subnetting is required? You tell me. You divide it into how many subnets? No? Oops, what did I do? Yeah, 32, someone said. – Go on. No? Anybody? Any guesses? 32, yeah. Well, 32 minus 2, which will give us 30 usable addresses, right? So you need to have the initial network, which had 256 addresses. Now you're going to split them into networks, which will contain 32 at least. So you will get 32 times 8, 256. So you've got 8 networks, subnets, times 30 each, right? Well, 32 minus 2. So this should meet the requirement. 30 will accommodate 25 each, and it will be suitable for that as well. And you will use 5 out of 8. You've got 8 subnets, so 5 you need. So 3 will be spare. So how many usable hosts? 30. If your answer is less than 25 hosts required, then you borrowed too many bits. So how many bits you need to borrow? This is the question. 3, yes. You're creating 8 subnets. Yeah. So you need to borrow 3 bits. So your subnet mask will be new subnet mask will be so in the 4th decimal octet, you will have 3 bits, 1, 2, 3, and so the number in a dirty decimal will be 255, 255, 255, and what is the last octet? Well, 224, yes. 3 bits will be 224. And then you need to fill in the numbers here. So you got 5 subnets you need, and you can have what is the first usable, what is the last usable. I think we need to lift it and put it in a Word document. Just give me a second. Copy and right. So what was the address? Yeah, here we are. We've got this address. So first subnet, we decided, right? So we need to now extend the subnet mask to 27, right? So the new subnet mask will look like this: 255, 224, or it equals actually /27, right? So the first network will begin at begin right here. Copy, and I will put it there. And increment is 32, isn't it? So is 32, 64, 96,
128,
128, and this
160.
160. And I think that's enough. Yeah, we don't need more. So what is first usable? First usable will be 1. Last usable so broadcast. Okay, I think broadcast is easier to see. So 1 before 32, which is 31, isn't it? And last usable will be 30. So So now, what is the broadcast here? All right. Okay. So 32, so 63, isn't it? This is the broadcast. So here we've got 33 first usable, last usable will be
62.
62. So broadcast here is just one before the next, so which is 95, yeah?
Yep.
So 65 is the first usable, last usable is 94.
4. Yeah.
Broadcast here is 127 and 97 is the first usable.
126.
126 is the last usable. Broadcast here is 159. So 129 is
158.
first usable, last usable is 158. And I think the last one,
191.
we don't need this. We only need 5 networks, so we don't need this. But we can, yeah, we can continue. So so what will be the next one? 181, right?
191.
Oh, 991. Yes, sorry, yes, of course. And so we 2.
161. 161.
And this one
190.
190. And we can extend it. So 2 more to fill in. If you want to. So the increment is 32, so 192. 192. And this one will be last 224. So the broadcast here will be 223, and broadcast here will be 255. All right. And one nine one, sorry, 193,
93.
and 222, 225, 254. So all eight we've done, right? So we can't go wrong here anymore. So this is done. Assign the subnets to the network shown in the topology. 0 will be we go to this. There's a bit of background noise, guys. It's coming from someone. So subnet 0 needs to go to LAN. Okay, let me put it like that, and I think I can fit it in so we can see what we're doing. So we need subnet 0, 1, 2, 3, 4. And first usable needs to go to first usable need to go to on R1. So on R1, router 1, we need to first usable in the subnets. So which subnets? 0, 1, and 4. Okay, let me just I think this will be easier if I write them here, numbers. So this is LAN 0, this is 1, this is 2, this is 3, and this one will be 4. So first usable will be here of LAN 0, subnet 0. First usable of LAN 1 will be here, and first usable of LAN 4 will be here. First usable of LAN 2 will be there, first usable of LAN 3 will be there, and there is one link here. This will be last usable of this. So first, yeah, because LAN 4 will have first usable assigned to router 1, and last usable will be assigned to here. So all following this guidelines. There's a chat. 102. Yeah, 100. Right. So here we are. Here we are. Just trying to fit things together so they can be seen on the same screen without jumping. Right, here we are. I think that will work. Okay. Assign the first. Okay. So we need to. Well, first we need to document this, right, and then do the actual assignment. Probably need to borrow that table as well. So otherwise we will
Teacher.
struggle. Yeah.
Yeah. When we'll submit the assignment?
What assignment?
Oh, you didn't give us any assignment. I missed some of the classes, so because of some a problem, so that's why I'm not behind. I can catch up, but I want to see the course module, but I can't find it. Course module. I went to the netcat.com, but there is nothing. I can't see anything for the course module. Would you please help me after the class?
Yeah, I don't understand. So you went to NetACAD, and which course module you're looking for?
You teaching us the CCNA course module. This is I'm trying to find, but I can't get it.
Why can't you? So it's here. In your Network Academy, you open Network Academy.
Yeah,
and you
netacad.com. Yeah.
Yeah.
But I went inside, but I didn't find that.
Didn't find what?
The module.
The course.
Yeah, course module.
Yeah. Let me see. Let me see. Let me just see. Your name is Mohammed Alan.
Yeah.
Alan. Well, you are suspended because you missed so many classes. So I just suspended you.
Who suspended me?
I suspended you because you missed 5 or 6 classes.
No, I missed only 2 classes.
No, you didn't miss. You missed quite a few.
Not quite a few, because do you know, I know some of these, and the subnetting you are supposed to do. I request you, please add me in this group, because I want to complete as soon as possible with you.
No, you're mixing two things. You know this stuff and missing the classes. I said because you missed classes. I don't know how much you know about subnetting. This is your knowledge. I have no clue about it, but I'm going by the attendance. If you miss many classes, you will be suspended. So I can put you back on, but it doesn't matter how much you know. I go by the attendance. Do you understand?
Okay, I'll from the next time, if I had problem, I'll email you. But I shouldn't have anything. Do you know the? I'll attend to the class. Sorry, I apologize for that.
Okay. No problem. So yeah. So you should be able to see it. I've activated you.
Please,
Yeah. All right.
please.
Okay. So
Now you already have you
yeah,
done
you just
that?
need to you just need to probably refresh your page or maybe log out and log back in, and you will be able to see the materials.
Okay, I'm doing that. Thank you very much. Thank you for your
Okay.
help.
So what we were doing here, we need to. Oh. So we need to fill in this table, which is a bit awkward. I will try to fit them side by side. So tables, right? So the requirement, first usable. I assume, okay, because I can't see now. This is awkward, isn't it? So G00 is the top one, which is so basically this is subnet 0, right? This one. So the first usable has to go to R1. And subnet mask will be the same for, remember the subnet mask? So that was /27, which is 224, right? So subnet mask will be 255, 255, 255, 224. Well, the default gateway it doesn't apply here because this is the default gateway anyway. So G01 is the next subnet, which is this guy, right? First usable, we need to assign to this router's interface. And subnet mask will be the same. I'm not going to repeat subnet mask. It will be identical for all the for all the interfaces, for all the addresses here. Subnet mask doesn't change. And S00 is the WAN interface, this guy, and it is first usable on the subnet 4, if I remember here. Yeah. So assign subnet mask 4 to one link between R1 and R2, and first usable from here. Assign the first usable to R1 and 2 LAN links and 1 link. So the first usable on that subnet 4 has to go to a serial link, serial interface of this router R1, the top router. So which one is that? This one. First usable of subnet 4. We're not using those, so I'm going to so we don't get confused. I will just exclude them. Maybe it was wrong actually. I need to fill them in somehow. Doesn't work anyway. So first usable is this subnet 4. I'll copy it and I will assign it to serial link here. And the last usable within the same subnet. Yeah. So subnet, we're going to, it's the same subnet between router 1 and router 2. First usable goes to the top one and last usable goes to the bottom one. So the last usable is here in the subnet 4. We copy this and we put it in there, in here, to the serial address, right? And router so and this is router subnet 2, first usable of subnet 2 of this one. Copy. It goes in here. And first usable of subnet 3 goes in there. I think this is correct. You correct me if I'm wrong. So this is done. Assign the second usable IP address in the attached subnets to the switches. So S1 will be second usable. So S1 belongs to this subnet, right? So second usable. Copy V, and second usable will be 2, one after one. This one is copy to switch 2, and second usable will be 34. This one, copy, paste, second usable will be 66. Next after 65, copy here, second usable will be 98. Right? So switches are done. Subnet mask doesn't change, so I can I think it will be the same here anyway, so nothing is going to change. And what else? Last usable IP addresses to the PCs. Okay, so last usable IP addresses to the PCs. So what is the last usable? In 0 is the top network, so this is the last usable, right? I need to assign it to PC. Okay. PC1. Last usable here will be PC2. Copy PC2. Last usable in 3. Not well, network number 3, but here it's because we count from 0 to 1, 2. So this is LAN 3, and we copy, and this will be PC3. And this is the last usable in LAN number 4, which is, oops, sorry, I need to copy it, not paste. Copy and paste right there. Yeah, everyone agree? So I didn't make any mistakes. I don't think so. What we need to do is just to have a default gateways. So default gateway for LAN 1 will be this guy. So who is in LAN 1? Switch 1 is there, and PC 1 is there, right? So this is the default gateway for LAN 1. For LAN 2, this is the default gateway, and I'm going to put it for switch 2 and for PC 2. For LAN 3, this is the default gateway. Copy, and S3 in there, and PC3 is there. And this is default gateway for LAN 4. So switch 4 will be there, and PC4 will be there, right? So we're talking about, you understand, yeah? So LAN 1, LAN 2, LAN 3, LAN 4. So I think we have fully completed addressing table here. You can take a screenshot. So this is the first part, first kind of table we did, and then the second one is like that. So you can take a screenshot. Tell me if you need. I can move it again so you can screenshot it. So I'll put it aside like so, and now we need to configure. So most of the IP addressing is already configured in this network. Implement the following steps to complete. So R1 needs addresses. So it looks like R2 has been configured already. So it's actually locked. So I can't even do anything here. PC1 also locked. So what do we need to do? Okay, so only router 1 and switch 3 and PC4. Okay, PC4. How? Why? Why PC4? All right, it is possible. So PC4 is missing something, right? So IP configuration. So I'll set them side by side. What is PC4? When you have this documentation ready, it's very easy, isn't it? Copy, paste. If I put subnet mask, it will pre-fill, but it's not the correct one. So we need to change it. Remember, we changed it to 224. And for PC4, the prefix, sorry, the default gateway will be this. Copy. There you go. So PC4 should be configured now. Completion 20%. we need, so what else? We need to configure router 1 in all 3 interfaces, right? No, it says both. Oh, only LAN interfaces. Yeah, not serial. So only LAN interfaces on router 1. So click on router 1, go to CLI, and enable conf-t. And so on router 1, we need interface G00, and we'll give it IP address 192.168.100.1, 255.255.255.224, according to this addressing table, right? Press enter, no shut, done. And now interface G01.
Pavel, so
Yeah,
I think you did a mistake. I didn't know the IP address 192.168. It is 100, not 1000, right? If you go up on your CLI,
yeah.
it should be
Oh,
100.
yeah,
Yeah.
10. Sorry. Yeah.
Uh,
Thank you. So
All right.
let me do this. Okay, 192.168, and I will correct that. 1 and 255. Sorry, not 1. Again, I'm making mistakes. So so router 1 G01 is 33, right? So let's pay attention. 255, 224. No shut. And so I need to go back to interface G00, isn't it? To correct it. So the proper way is actually to say this. Yeah, so this is the what I missed. Instead of 100, I said 110. So I need to say no. I basically removed the IP address, and now I need to use it again, and this time I will correct it, and I will use 100. How about now?
So Pavel, you can't just say
No, you
IP
can,
address
you
again.
you can. But sometimes it can lead to some. If it is live equipment, it might. I mean, you don't. You need to shut down, reassign IP address, and shut and switch it back on. Kind of. I mean, here it doesn't matter, to be honest. In Packet Tracer. Right. So
You need to do no shut again for that, yeah? For that new one.
no, I didn't switch. I didn't switch it off. So it is on. I didn't
Okay.
switch it off. I just misconfigured. So you can see it's green light, so it's on. And what else do we need to do? 66%. IP address on switch 3. So VLAN 1 interface addressing and switch with default gateway. So that's two configuration we need to do. And so did it say switch 3? Yes. So switch 3 needs to have, so CLI enable conf-t. So interface VLAN 1, right? And we need to give it an IP address. IP address 192.168.166. I'm going by this table. 66, 255, 255, 255, 224. No shut. Exit. And I need to say IP default gateway. By the way, I use my, when I say this and I press tab on my keyboard, it auto completes. Yeah. IP default gateway and is at, so for switch 3, you need to be careful. what is the, so this is the, for switch 3 is the default gateway. 192.168.165. It is 65, yes. I'm just double checking. Yes. Completion 100%. All good. So it looks like we did everything correctly. So now to check all of this, we can't. It's only PC4 that is accessible. So from PC4, we can ping stuff, it looks like. So what can we ping? Shall we ping PC1? So ping 198, yeah, 168, 100, and PC1 30, shall we? ARP, remember ARP? There you go. Control C to break it, and now PC2 62. Control C, so it's all good. Now 94. Looks good. So what else? A couple of switches maybe if we need to. So ping 2, which is switch 1. See if that one can be reached. There you go. It took a bit of time, and then next will be 34. So you not only configure, you also test, isn't it? You have to do it. So there you go. And then the last one is switch. Okay, we will do all switches, I guess. So 34, then 66. This is the one that we configured. Now you see why pings have to be sent in not just one, not even 2. So 4 usually is enough. So by the way, if I send a ping to the same address to the same switch now, because there is no need to perform ARP, it's not going to.
Will you please ping from PC1 to PC4?
I can't, because PC1 is locked in the packet trace. It's not accessible.
Why? Because if you configure the router, so if you configure, do you know router, both router, there is no connection. If you make the connection, then PC 1 to PC4, PC1 to PC3, PC1 to PC2, you can. So I want to see that.
Yeah, I want to see it as well, but it's not possible. Yeah, because the PC1 is locked. If I click on PC1, it says change. It is locked, not accessible. You understand?
Who logged it? This is you logged it or someone?
Yeah, this is the one author. So if I click on it, it says author's design for this activity. It's locked.
Okay, I got it. I got it. When we'll supposed to do myself, then we can supposed to. I got it.
Well, if you want to recreate this packet tracer, yes, you're welcome to do it. But at this moment, it's not possible. All I can use is PC4. That's why I'm pinging from PC4. Yeah, only PC4 is accessible.
I'm asking, do activate the router to router, because there is the red line, router to router. So if you're supposed to activate router to router, then from PC2 to PC4, we can communicate. Am I right?
I've just pinged from PC4. I pinged PC1, PC2, PC3, S1, S2, S3, and everything was successful. Do you think this is activated or not?
I don't think that this is activated. If it is activated, then it will be, oh, is it activated? Yes.
It is activated. It's just red, not because it's not working, because it's a serial connection. It is red.
Okay. Okay.
Yeah. If you did packet traces before, you must have seen this. No? So this is just red because it's just serial connection. That's why it has a red color, not because it's not working.
Okay. Okay.
Right. Okay. So there you go. So I think we pinged everything, right? Maybe the last switch 4 we didn't ping, just for completeness. I think it's 98. There you go. So we from PC4, which is the only one that is accessible here, allowed by the author of this packet tracer. So only PC4 is accessible. From PC4, I pinged every single destination and everything was successful. So all of, well, it means that everything works within the what's allowed here. So we can do all the available tests. So there you go. Now, yeah, I think we need to continue. Let me just see what's next. And okay, okay, guys. So you've got it right. So the only problem here was to design this scheme, I think. So if you took your screenshots, you'll be fine. This is what is difficult here. Our assignments are not right. Oh, VLSM. Yes, I think we need to break. Yeah, I think we need to go on a break, and because next is variable length subnet masking, so subnetting, which is going to be a new concept. So I think we better do it afterwards, after the break. Right?
How long is the break, sir?
1 hour.
Okay. Okay. Thank you very much.
Yeah, so until Q2. So Q1 now. Q2, please come back, and we'll have to finish it today.
Yeah, but I'm asking you, teacher, because this is the break time. So because I missed something. Now, which module are you teaching to now?
11.
11. Okay.
Got pushed back into my room.
By who?
My subconscious.
All right. So let me just quickly mark who is here. Jason Johnson. Yeah. Collins. Do we have Collins? Yep. Just 1 minute. Samuel. We have Sema, Jimmy, Jeffrey Lillian. Ahmed Sharif. Yeah, marked. Sema is here. Sema. Ahmed Asim. Ahmed Asim Ayub. No. Sema is here. All right, I think I'm done. Just let me find Sema. Yeah, Sema. There you go. So what we wanted to look at, yeah, someone said more subnetting. So before the break, we looked at splitting a subnet into equal parts. Yeah, so you've got something to begin with, like that. Yeah, so this is your subnet, and then you can split in half, or maybe 4 equal parts, or maybe in 8 equal parts. Yeah, and like we saw in the packet tracer that we did just before the break. Remember, there were 4 LANs, and there was one link between 2 routers. Remember, 2 routers. So router 1, router 2, and some LANs here, right? 2 LANs on each router. So yes, 25 hosts there, 25, 25, 25. But here, we only needed 2 because it's a serial link, and there is only 2 interfaces on that link. There is no other participants. Yeah, so there is no other addresses are needed for this for this subnet. But we still used a whole 30 IPs subnet here. Remember, we used one of the subnets we created. So 28 out of those will be unused. We only need 2. So what variable length subnetting allows us to do is to use different sized subnets for different parts of your network. So you can have 25, 25 here. You can have, if you need 25, 25 there. But here, because you only need 2, you can have different size subnet. So for 25, remember we needed /29, yeah? Sorry, 27, yeah? So /27 was the subnet mask for those. But here, we can get away with /30. /30 gives us 2 host addresses, yeah, maximum 2 host addresses, but that's as many as we need here. We don't need more. So this is what variable length subnetting is. So you have your original network, and then you split it into different sized subnets. So let's say you can have one subnet which will have 126, half of your original octet. Then you might have here another subnet which will contain 62 addresses maximum, yeah? Then you might have 32 here. It will be the other way around, probably. So something like this. So you've got your original octet. You split it in, so here you've got 126. And this one you leave alone. You don't, let's say you've got one network where requirement is to have at least 100 addresses. So you have to keep it at 126 size. But the other networks, as you have in your organization, are smaller in size. And so you might have this 62, right? So 62 addresses, and then you can have this 30, and then you can have even further. You can start continue splitting and subnetting other just bits of your network, not all the subnets, not to keep all the subnets of equal size. Yeah, so you don't subnet into the same size subnets. That's what it is. That is variable length subnetting. There's a video which explains exactly that. And I think we probably need to, okay, let's watch that video. We've got time, I guess. Let's have a look. There are a couple of videos, one after the other, and there's sound. How long is it? 2 minutes, not too long.
The basics of VLSM, or variable length subnet masks, works like this. 1. Subnets do not have to be equal sizes, as long as their address ranges do not overlap. So we can create unequal sized subnets. They do not all have to be the same size. 2. When creating subnets, it is easier to work from larger to smaller subnets. So for example, I have the 192.168.1.0/24 network. I subnet the network into 4 subnets /26 subnet masks, so the subnets go up by 64. I now have 4 equal-sized subnets. With VLSM, or variable length subnet masks, I can decide that I want to change one of these subnets and further subdivide them into smaller subnets, as long as the address spaces that I create, or the subnets that I create, do not intrude into the other subnets. For instance, I could take this 192.168.1.192 subnet. The address range for this subnet goes from 192 all the way up to 255. What I can do is I can say, instead of having this subnet /26, what if I take that address space and divide it into 2 smaller subnets size /27 each? If I do this, I effectively have created 5 subnets. The 3 subnets up here are 64 hosts each, and the 2 new subnets that I created from the 4th subnet are 32 hosts each. The reason I can do this is because my 2 smaller subnets do not intrude into the larger subnets. This is variable length subnet masks. In this situation, it has also allowed me to create 5 subnets, thus escaping the equal-sized subnet limitation of creating subnets in powers of 2. This gives me greater flexibility and allows me to create subnets of different sizes based on the requirements of my network.
Okay, so you understand the purpose, right? So now, after understanding the principles of subnetting, now you can play with the subnetting. You can subnet something, you subdivide some other subnets while keeping the sizes of some others. Yeah. So this is variable length subnetting. Who is going to stop you? So no one. There you go. This is a long one. It's an example.
In this scenario, the task is to subnet the 172.16.0.0/23 network to create the following subnets: 1 network for 200 hosts, 1 network for 100 hosts, 1 network for 50 hosts, 1 network for 25 hosts, 1 network for 10 hosts, and 4 point-to-point networks for 2 hosts each. Before I begin to create these subnets, I need to check to see if I even have enough addresses in this address space to create all of these subnets. So by writing out the network and the subnet mask in binary, we see that we have a /23 subnet mask. Here's 23 ones in.
So he begins not with traditional on octet boundary subnet mask /24. He begins with /23. Yep. So just in this example, yeah? And he checks if all these addresses that he needs, all these networks that he needs to create, can actually be can actually be done. He can actually fit this address space.
Binary. The last bit is in the 2's place. If we look at this 8-bit grouping in the 3rd octet, we see that the last one is in the 2's place. That means the subnets would go up by 2. So the next subnet will be 172.16.2.0/23. So the address space that we're working with goes from 172.16.0.0 all the way up to 1.255. Let's see if this is enough addresses to create all of these subnets for this specified amount of hosts. I can see that starting from a /23 subnet mask, we have 9 host bits, so effectively there's 512 hosts. If we look at each one of these subnets that we're going to need to create, I cannot create a 200 host subnet, but I can create a subnet for 256 hosts. That number does not reflect the usable hosts, but the total number of addresses in the subnet. Similarly, I'm unable to create exactly a 100 host subnet, but I can create a 128 host subnet, a 64 subnet, a 32 subnet, a 16 subnet, and 4 host subnets will satisfy these requirements. If I add up all of these numbers, 256, 128, 64, 32, 16, and 4 subnets of 4, the total number is 512. So I'll have exactly enough host addresses to create these sized subnets and meet the requirements. Once again, these numbers here for the subnet sizes that we'll create do not reflect the usable host addresses, but the total number of addresses in the host portion of the subnet ranges, including the network address and the broadcast.
So actually, the process of might be actually in real life might be going in the opposite direction. So these are your requirements. This is what you need to create: 200, 150, 25, 10, and 4 by 4, yeah, networks. And this is what your business needs. This is your organization. You are employed to design this network. And then you need to calculate, and then you need to tell your manager how much they need to spend, because this will be like, maybe it's, well, in this case, it's a private address, it doesn't matter. But let's say if I don't know, maybe there is some other reason, it doesn't matter. Why, yeah, so, but if it was, obviously, if it was public addresses, that they would need to buy /23 address somehow. But here, so it doesn't matter the reasons and the costs or anything. But so you would pick the correct network which will satisfy your requirements. So requirements come first, obviously, yeah, because that's why you actually do your networks. So you create your networks because your business requires this. It's not like you've got a network and then you come up with ideas. How would you like to subnet it, just for the fun of it, right? So it's not the case. Okay.
Address. So let's get started subnetting this network using VLSM, variable length subnet masks, and working from largest subnets to smallest subnets in order to create all of the subnets required. So working from largest to smallest, the first thing I need to do is to create a network for 256 hosts to satisfy the 200 host requirement. What I can do is I can subdivide this single network of 512 hosts into 2 smaller subnets of 256 hosts each. So instead of having a 172.16.0.0 network /23, I change the subnet mask to /24. This creates 2 networks, 0.0 and 1.0, each subnet having 256 or 8 host bits. Notice how the subnet mask has changed from /23 to /24, and I now have 2 256 host subnets. What I can now do is keep the first of these subnets and subdivide the second one. To do this, I simply take this 172.16.1.0/24 subnet and change it from /24 to /25. So now I have the 172.16.1.0/25 subnet. This creates another subnet, 172.16.1.128, both subnets have a magic number of 128, meaning the networks go up by 128. So I've taken this one network of 256 hosts and subdivided it into two networks of 128 hosts each. Now I have a subnet to meet this second requirement. Moving on from there, I'll keep the first of these subnets and then further subdivide the second one. So now we no longer have the 1.0 network in its place. We have the 1.0 subnet and the 1.128 subnet. Then I subdivide the 128 subnet into two smaller subnets /26 each. So now there's no longer a 128 subnet, there's two subnets in its place, a 128 subnet and a 192 subnet. Both of these subnets have a /26 subnet mask. If I was to write this subnet mask in the binary conversion table here, we would see that in the fourth octet, /26 means that the last one in the subnet mask is in the 64's place, and the networks go up by 64. Furthermore, with the /26 subnet mask, you only have 1, 2, 3, 4, 5, 6 host bits, and 2 to the 6th power is 64, meaning there's 64 hosts, 62 usable per subnet. I now have my 256 host subnet, I have my 128 host subnet, and my 64 host subnet. I can subdivide the second of these two subnets into two smaller subnets of 32 hosts each. To do this, I take the 192 subnet and subdivide it by changing the subnet mask from /26 to /27, creating two subnets of 32 hosts each. So now I'm no longer using the 192 subnet /26, I'm using it as a 192/27 subnet and a 224/27 subnet. From here, I still need a subnet for 10 hosts. I can take the second of these two subnets for 32 hosts and subdivide them to two 16-host subnets. To do this, we take the 224/27 subnet, change the subnet mask from /27 to /28, and now I have two smaller subnets. From here, I take the second of these two 16-host subnets. I only need one. The second one I'll use for 4 subnets of 4 hosts each. So now instead of the 240/28 subnet, I have the 240/30, the 244/30, the 248/30, and the 252/30 subnets. Looking at the subnets that have been left, we have the 172.16.0.0/24 subnet. This is good for 256 hosts. We have the 172.16.1.0/25 subnet. This is good for 128 hosts. The 172.16.1.128 subnet /26 is good for 64 hosts, and the 192/27 subnet is good for 32 hosts. The 224/28 is a 16-host subnet, and then the last 4 subnets /30 each, 240, 244, 248, and 252, are good for 4 hosts each. Once again, these sizes do not reflect the usable hosts in each subnet, but the total number of addresses in the host portion. For usable host addresses, you need to -2 from each subnet. If we examine the host addresses closely, we'll see that none of the subnets overlap. In other words, this 172.16.0 subnet goes from 0 all the way up, since it's /24, to 255. You can see that the next subnet starts at 172.16.1.0, so the two subnets do not overlap. Similarly, this second subnet goes from 0 to 127, and we can see that from host 0 to 127, the next subnet at 172.16.1.128/26, that there's no overlap. This subnet ends at 127, the next subnet begins at 128, and so on and so forth. In the end, we've created 9 subnets of different sizes: a 256, a 128, a 64, a 32, a 16, and 4 4-host subnets. This is VLSM, and it allows us to create subnets or networks specific to the needs of the network.
So what he did, basically, he divided what he had in 2, left the first half on, and then divided the second half again into 2 halves. Then left out of that second half, first half intact, 128 addresses, and divided the second half into 2 64 ones. Then left the first 64 and divided the second one into 2 32 each. Then left out of those 2 32s, left first 32 untouched, and started dividing the second 32 addresses into 2 halves of 16 each. Left first 16 intact, and then the second 16 he divided, this time not in 2 but in 4 each. That's what all he did. And he began with 512 addresses, and he ended up with 512 addresses. But now they all don't belong to the same network. They just split into how many? 1, 2, 3, 4, 5, and 4 small ones, 9 subnets altogether. Yeah, that's what he did. We're going to do a bucket tracer somewhere, so hopefully it will be better understood. And what I did quickly Googled, and I did Googled subnet to CIDR, and it gave me, I mean, there are multiple resources. It's very well-known topic. You will find lots of resources. So things like subnet mask, how many addresses are there, and blah, 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 how number of relation to /24 network. Why has it moved now? All right, there you go. So can you see? So subnet mask, CIDR notation, how many networks, how many addresses per each subnet, and how /24 network, what is the relation? So this is 1/8 of /24 network. Here you would double /24 network, right? And so on. So it's not the best maybe resource. I've just quickly Googled, and it gave me this. You can Google it yourselves. Yeah. Special case, quad zero, anything. The entire 32-bit address space. Yeah, can you see this? Also, subnet mask 255.255.255.255, which is CIDR prefix length 32. That means just one single address, just one single IP. Yeah, /32. That's what it means. Right. Here any enthusiasm, but anyway. So two videos we've looked at, we watched, and so why would we require variable length subnet mask? So in this slide, you can see there is with this topology, you've got your needs are you have 25 hosts, 20, 15, 28, and 2, 2, 2. So you need 7 subnets altogether, right? You could split if you have /24 network to begin with, then you could split it into 8 networks, 8 times 30. That would satisfy the needs. But so here you would be using only 2 out of 30. And this is basically a bit of a waste. So if you use equally sized subnets, if you use variable length subnetting, so here a calculation, what a waste would this mean? You would have 84 unused addresses if you used equally sized subnetting. But if you use VLSM, so you can have /30 here, /30/30. So only 2 addresses are required, and that's what /30 gives you. So no addresses will be wasted here on this 3, and obviously this 4 will be still 30 each, right? And the pie chart shows you, so 8 addresses, 8 subnets, 30 hosts each, all equally sized, or you can have, and in that scenario, if you used equally sized subnetting, then because you require 7 subnets, you will be left with 1 spare one, right? So out of 8, 7 you will be implementing in here in this topology. But with VLSM, you've got you need 1, 2, 3, 4. So 1, 2, 3, 4 will be used. This will be spare, 3 more subnets, and out of this you only need 3. 1, 2, 3, and again 5 more smaller sized network subnets will be available. So if you need to expand your business, I don't know, you can add something else. And this is how it looks like if you use this VLSM, variable length subnetting. So this is more efficient design. No wasting. Well, there is some wasting of addresses. So you're not using 30, you're using 25, 20, 15, 28. Some of addresses are being unused, but this requires gives you a little bit of a room for expansion, so you can add more devices. But here you will never use more than 2 links between routers. Will never be no other participants, no other interfaces will be introduced to this link. It's going to be always a link between 2 routers. That's it. Why would you use a subnet which has 30 IP addresses? You can get away with /30, not /27. Yeah, so with 2 addresses, not 30 in each subnet, and this is more efficient design. So when you plan your network, this is a big task, by the way. Yeah, so it's not something you want to make mistakes with, and so it has to be someone experienced and capable of this, who will be designing this, or who will need to design this, because it's easy to make a mistake here. So planning is crucial to develop a scalable solution to an enterprise network. It has to be scalable. Scalable meaning that if you add something else, it should allow you without changing. It's not good design if you want to add like an extra site. Yeah, your business is expanding. You've got a new building, and you need to add that network to your existing network. It's not a very good design if you need to redesign your existing network just to allow this expansion. Your existing network should provide this expansion option to expand without the major adjustments needed for your existing network. So the scalability needs to be there in the first place, from the outset. And this is a good design, obviously, much better. So you need to develop IP network wide addressing scheme. You will need to know how many subnets are needed, how many hosts in a particular subnet will require, what devices are part of the subnet, which parts of your network use private addresses, which will use public, the ones that will face your public, like the demilitarized zone or something, and many other determining factors. Examine the needs of an organization network usage and how the subnets will be structured. Perform a network requirement study by looking at the network, at the entire network, to determine how each area will be segmented. So you basically have to observe and understand how your HR department, your students' classes, how many networks will be there. What if your design structure of your classes will change? Can you accommodate this, and how, and all this? Yeah. Determine how many subnets are needed and how many hosts per subnet. Determine DHCP address pools and layer 2 VLAN pools. Well, we haven't looked at any of that, but basically this needs to be taken into consideration. What is this? What is DHCP? What is VLAN? We'll look at some stage later on. So, who will need an address? If it is an PCs, desktop PCs or whatever, they will need most likely DHCP, automatic IP assignment. This is the easiest implementation. You don't want to manually assign hundreds or thousands of IP addresses to your workstations, yeah, so your PCs. This is not something convenient or needed at all. So usually it's being assigned automatically by employing DHCP service. This is what your computer, when you join your home network, broadband, whatever your network you've got, and then this is what normally happens. You don't participate. You don't even know how your computer gets an IP address. This is usually done by employing DHCP. What is DHCP? We'll look into at some stage, yeah, later on. IP version 6 clients can obtain address information using something which is called DHCP version 6. DHCP, which is designed to work with IP version 6, and Slack. What is Slack? We'll come to this. Yeah. So this is basically IP version 6, a feature of self-assigning addresses. So if you have a server peripheral, this should have predictable addresses, so they need to be static. You can't have a server which will change IP address from day to day. Your server or your printer, they will have to have static determined IP addresses which will stay the same. Otherwise, your server won't be found, or your printer. You want to print, and yesterday it was at address 127, and today it is at 135. How are you going to find it? It's a challenge. Yeah, so you don't want to do this. And servers that are accessible from the internet are accessible on public IP address. They will be most likely accessed via NAT, network address translation. This can be done, or they can be used on they will have public IP address, IP version 4 address. Intermediary devices, this is your routers. They should have addresses for network management, router switches, monitoring, security, so your firewalls and so on. If you need to access those devices to configure them, they need to have addresses. Usually only accessed by administrators. And gateway, routers and firewall devices that are gateway for the hosts in that network. So all of this needs to be carefully designed, and an IP addressing scheme needs to be produced. So you need to, usually you need to have some set pattern of how addresses are allocated to each type of device. So if you decide that within a given subnet, within this given network, you allocate first available IP address to a router, which will be your gateway, so be it. Or you might choose to allocate the last available address to the router, if this is your how you want it to be. Fine, but stick with this rule. So all your routers will all have last available usable address within each of those subnets. Yeah, it's like naming convention. You follow the same rule, so it's predictable, and you don't need, because if your router in one subnet, your default gateway has a first available address, and the next subnet has your gateway has a last available IP address, it will create confusion for everybody, yeah, for everyone. So just stick with one rule, which is predictable, and it should be fine. So you might have some addresses, for instance, servers. If you have DHCP employed, then you will have a pool of addresses available for a DHCP. Servers and peripheral printers, which will have static addresses, they will have to be taken out of DHCP pool. So DHCP will not try to assign those printer and server addresses to some other devices. So the DHCP has to boundaries have to be set, and DHCP will not be playing with your static addresses. So some rules. Yeah. How is this? Hopefully it will become, when we talk about GCP and other stuff, hopefully it will become a little bit clearer. But for now, just have an idea that it has to be designed, right? So obviously, right? And some considerations like business requirements and future scalability, security, and all this. Lots of considerations. So there is a packet tracer, and this is the end of this module. And hopefully, if you practice this, it will settle with you. Let me just get it. Cisco Networking Academy is right. So my packet tracer right here. So you need to practice this stuff, guys. Even if you follow me and you think, oh, I understood, you still need to practice. And then it will kind of become a little bit easier. Promise you. So share this.
Teacher, I have a question.
Yeah.
One real IP address, how many subnetting we can do? With one real IP address, how many computer we supposed to configure, like with the VLSM?
I don't understand the question. How can you, with one address, you can't subnet one address. It has to be a network.
Yeah, one IP address, one real IP address, how many subnetting I can do? 256 or 500?
You can't subnet one single IP address. One single IP address is a single IP address. It cannot be subnetted. If you're talking about IP address, if you're talking about network address, it depends on the size of your network. No,
yeah,
where you begin. Sorry.
This is the network address. Yeah, one network address. How many subnet can I do?
But what kind of network are you talking about? It depends on what network it is, isn't it? If it is a large network /8, you will have 60 million networks. If you have a /24, then you have what your options are limited. We went through this today, didn't we? So you saw how many networks can be created. You can split it in half. You can have split it in 4, in 8, 16, 32, 64. That's it.
Yeah,
So
if is CIDR values, for an example, 18/18.
But we've just covered this. What do you mean /18? We just
This is the
it's like you've never been here. So just give me a second. Paint. So /18 network, yeah?
Yep.
So so you've got in the last octet, you've got 110 sorry, no, what am I talking about? So this is it, right? So this is the octet number 3, and last octet will be this. So how many networks you can create? Is this your question?
Yes.
So you've got this many to begin with. So you've got 2 to the power of what? 14 hosts in this subnet. So you've got sorry?
A lot of.
A lot.
Yeah.
This is the hosts. And then you can split it. You can split it in 2, in 4, in 16, I don't know, 512,000 networks, subnets.
Okay.
Right. So this is the packet tracer. Okay, packet tracer, VLSM design and implementation practice. This is the number. Okay, I'm going to download it and open it up, and let's quickly do it. The name is VLSM design and implementation practice. Yeah, practice. Beautiful. This is what we want. Practice. Here we are. Oh, ooh, beautiful, isn't it? So, the requirements. It looks like we've got, it's already on the topology. So you've got 60 hosts in the top LAN. Then you've got another LAN where 30 hosts is the requirement. Then you've got 14 hosts and 6 hosts. So 4 LANs and one link, this red serial link between 2 routers, which will need 2, right? So only 2 addresses. We need to fill in this device, sorry, the addressing table. You see, this one is interesting. So this packet tracer will be different for everyone. There are 3 possible topologies, so it's like a lucky dip. There will be along the similar lines to create VLSM, to use VLSM, but which exact topology you will get, there are 3 of them, so it depends. Yeah, so you can get exactly like mine, or you can, there are two more varieties, 2 more different other topologies. But the principles will be the same. So examine the network requirements, and design the VLSM addressing scheme, assign IP addresses to devices, and verify connectivity. So examine, design, and then assign. So you begin with a /24 network to use it to design VLSM addressing scheme. Based on the set of requirements, you will assign subnets and addressing, configure devices, and verify connectivity. So there you go. This is your starting point. This is your network you're given. And then you need to split it into 4 unequally sized networks, right? One will be 14, 30, 6, and 60. How many subnets are needed in the network topology? You need 5. 4 LANs and 1 between 2 routers, which is a 1 link. Yeah, so this is a fifth network subnet. So you need to determine the subnet mask information for each subnet. So, right. let me just paste it into my processor. Delete. There you go. And this, right? So and this is what your network is. So here, 14 hosts. What will be the subnet mask, right? So how many? Yeah, well, let's see. What? Sorry?
16. 14 host. One broadcast, one is the broadcast address, and one is the gateway.
Yeah. And what is
So,
the subnet mask?
oh, what is the subnet mask? Okay.
Yeah, what is the subnet mask?
If it is port 16, okay. 2 to the power 4, 2 to the power 4. 32, 4.
Anyone? Anybody?
It will be
28.
Come again? Sorry?
28.
28.
Yeah.
Yeah. Yeah, 28.
128. No. Oh,
Thank you.
yeah. This is 28. Yes. Sorry. Yeah.
So,
Slash 28.
and here?
Here is at slash 30.
That's it. So what is the subnet mask? It's not 30.
Oh, subnet mask. Yeah. It will be 32. 254.
Well, it should be shorter than the one that you just gave me. It should be just one shorter, no?
29.
Huh?
29.
Shorter, 27. Not longer, shorter. If you make it longer, you will have fewer addresses. You will have only 6. 29 will be here. No?
Oh, 20, 30. Yeah. This is the 28, 20. No, 29. 60. This is the 60. 64. It will be 64.
This is what where we begin, right? This is 24.
Yes.
It gives us how many? 256. Right. So slash 25 gives us how many addresses? Not 256 minus 2, right? Minus 2, 254. If I increase it, make it longer to the right, it will look like this. Yeah. What is going to happen if I make it longer?
That's false.
Yeah, so the address space gets smaller. If you increase the subnet mask, you create more networks, but each network will contain fewer addresses. So yeah, so more networks, smaller address space per each network. So in here, you will have 126. Then you've got /26 subnet mask, and the address space shrinks. You've got how many? 62. 27. You've got what? 30. Oops. Now you've got /28. How many addresses you can have? You can have just 14. And then next one is /29. You increase your space. Yeah. And then increase your number of increase your subnet mask, increase number of networks, but you decrease your address space. So address space will shrink to 6. Yeah. So here, yeah, remember you increase the subnet mask, you create more networks, 2 to the power of 5 networks, and 2 to the power of 3, you've got hosts, which -2, so 6 altogether. Yeah, so here you've got 2 to the power of 4, which is 16. 16 networks, 14 addresses per each subnet. So here it is. This is the table. I don't know. Take a screenshot if it helps. But it's very easy because you've got this 2 to the power of n. It's very easy to remember. You don't need to come up every time with new kind of way of calculating stuff. So for 60, if we need 60, so we need /26 subnet mask. So the other last option we've got is /30, where we've got only 2 host addresses.
So would you please tell me SW for switch for LAN 60 host and IP address /26. So it will be 255, 255, 255. Then last what will it be?
What you can't convert this to so what convert this to decimal. So what is /26 is this, right?
Yeah.
So you need to convert this into decimal. What will it be?
Okay, 128, then 64. Right. 255, 255, 255. Okay.
Right. So all right. So how many subnets are needed in the network topology? 5. And then which subnet mask will accommodate the number for this network, for that network, for that network, for that network, and fifth network will be between the routers. So between the routers, we need /30. This yeah, because we only need 2 addresses. So this is what /30 network will give us. So this between the remote site 1, remote site 2. This is a one network between 2 sites. So now we need to design the VLSM addressing scheme and divide the this network based on the number of hosts per subnet. So use the first subnet to accommodate the largest LAN. And second subnet, the second largest. Third subnet, third largest. Fourth subnet, fourth largest. And fifth subnet will be this smallest /30 site. Not site, network. So here is the subnet table. I'm going to copy this. paste it there. Right. So subnet description. Well, this is the subnet descriptions, right? Okay, so these are the names. Number of hosts needed. Okay, it's SW1 needs 14. Oh, we've got it. Okay, 14. SW2 30. How many hosts? SW3 needs 6. And this one needs 60. So network address CIDR. So CIDR, how many? Right. So 14. We need /28, right? But we need to give it a network address. So, okie dokie. So, first, use the first subnet to accommodate the largest LAN. So first we need to split it into how many? Into 4. And yeah, so this will be the first out of 4. So what is the address? This is the address. Copy, and this will be our first address. And this is this network address, and this is /60. We /26. Yeah, so we splitting this original network into 4, 62 each. And this is the largest, and we'll make it number 1, right? This is according to this. First subnet will accommodate the largest LAN. So first out of this 4, we just split. So one will be 48.0. This is number 1. The second one will be 48.64, then 48.128. So I can write them down. Okay, let me just write them down. What we have done. We have now 4 subnets, right? So this will be /64. This one will be 128, and this one will be 192, isn't it? Yeah, 4 subnets. This one we're going to use for the largest, for SW, and we're going to put it here. This is the network address of our subnet. We are done here with this subnet. So the first usable here will be that 1. Broadcast will be which is the broadcast, which will be 63.
63.
Yeah?
63, yep.
So there you go. Now, second largest, which will be this. So now we're splitting this.
Yeah.
We're splitting this into 2. So that this will create 2 networks /27. So we can make, I can do something like this. So this will be copy first network /27, and the second network will be. So what is the second? Plus 32, right? The increment here is 32. So 64 plus 32 is 96, isn't it?
96, yep.
So this is 27. So 2 networks. So this doesn't exist, right? Anymore. We split it into 2. And the second largest, which is this, we're going to use for SW2. All right, so copy, we're going to put it right there. First usable here will be
65.
no, this is wrong. Oh no, it's right. Yeah,
10.11.
it's right. Yeah, 65. Yeah. All good. 65. And the last
95.
usable will be 95, right?
Yes.
Yeah, just before the next network begins, which is next network is at 96. So 95 will be the one that is broadcast within this network. Perfect. Now we need to split. So we use this one. Yeah, that's it. So now we need to split this one into two, which will be 14 each, right? So this network we can split and I'll put it here, and the second one will be so both of them will be /28, right?
8. Yeah.
So this will begin at 96. Yes, we'll leave it like that. But this will be plus now the increment shrinks. Before it was 32, now it's 16. So 96 plus 16 gives us what? 112, yeah?
112. Yeah, 112.
There you go. So now we've got, this is our last third largest network, which will accommodate 16 addresses. So we're going to use it here. Right, oops, right there, yeah?
Yep.
So the first usable here will be 97, and broadcast will be one before 112, which is 111.
1.
Yeah, done. So now we've got this one unused, and we can split it into two still, and
It will be 29.
will be 29. Yes.
229.
Yeah. So 29, and the second.
13. Yeah.
Oops, what am I doing? Losing my marbles. Control V. So 29. But the address of the second one, it will be, so the increment now is 8, isn't it?
Yes.
20. So this will be 120.
Yep.
And so we're going to use this as our network, which will have 6 addresses in it, right?
Yep.
And then, so the first
13.
usable will be 13.
And 19. 119.
Yeah, you're right. Yeah. So now we've got, we still haven't used any of those. Yeah, they're still waiting to be used. So these are for expansion, but we've got this one now to split into, so it has 8, I don't think we can, oh, we can, yeah, we can split it in 2, because we only need 1/30 network for our subnet between the routers, right? So we can split it in 2 still. Why not?
— 20 to 24. 21, 22, 23, 24.
So we need to change
30.
it to 30. Increment will be 4, right?
Mm.
So the next will be begin at
24.
124. Yeah, and we can use this one.
Yeah.
This will be our last subnet, which is here. This one only needs 2 hosts. So the first usable will be 121
and 23.
120. Yeah, 123 will be the broadcast. Yes.
Broadcast.
Everybody, yeah, everyone follows. I don't know. I hope so. We haven't used that. So those two, so half of their address space, we haven't used at all. We haven't touched, and we haven't used this one, so we can actually move it here. We didn't use it, so we can call them, I don't know, spare something.
This is for future.
Yeah, for expansion. So we can have this, that, and this 3 still ones. So there you go. So now we need to assign IP addresses to devices and verify connectivity. Most of the IP addressing is already configured on this network. Implement the following steps to complete the addressing configuration. Configure IP addressing on the remote side 1 router LAN interfaces. So we need to go to remote side this one router, remote side LAN interfaces, which are why can't we see the so G how is it G01 and G01, both of them? It can be. So it must be G00 going upwards and G01 going downwards from there. So G00 belongs to SW2. G00. So SW2 is this. Right? And this is remote site. Well, show IP interface brief. Okay, so there you go. It shows us what the existing configuration is. So we only have serial interface configured. So G00, G01 are still needed. They need configurations. So G00 goes to SW2 network. Okay, so this is what we're going to configure first. So conf T interface G00 and it's SW2. So let's check. Oh, it says, so the first usable goes to the interfaces, basically, to your interfaces. So what is the first usable on SW2? SW2 is this, right? So let's give it IP address 10, 11, 48, 65. And the subnet mask is 27. So 27 is what? 255, 255, 255. What is 27? 224, right? Slash 27. Correct? Yeah, SW2. That's right. Done. And no shut. And G01 goes to SW1. So we're talking about this address now. So interface G01 and the IP address should be 10, 11, 48, 97. And subnet mask is /28. So mustn't do any mistakes. So /28 is 240, isn't it? No shut. So this is it. Now, let's see what needs to be done. So on remote side router, only LAN interfaces. Okay, Done. Configure IP addressing on switch 3, including the default gateway. So what is switch 3? Okay. Second usable address should be assigned to the switches. So what is the second usable on switch 3 network? So switch 3 is this. The first usable is that. And the second usable should be 114. Yeah, so find switch 3, enable conf-t, and interface VLAN 1, and we need to give it an IP address, switch 3, 10, 11, 48, 114. This guy, yeah? 114, second usable. So this goes to router interface according to this scheme. It says here, right? The first goes to the router interface, and the second goes to the switch. And subnet mask here is 29. So 29 is 255, 255, 255. What is 29? Anyone? Anybody? 2480, 248. Yeah. And no shut. And when I exit from here, I need to tell my switch how to find a default gateway. So default gateway will be this address for switch 3, right? So default gateway is at 10, 11, 48, 113. Done. What else? Configure IP addressing on user 4, including the default gateway. On PCs, we need following the rules that we created, right? So these are the rules, our naming convention. First goes to the router, to the default gateway. Second to the switch. Last to PCs, to the PC. So on PC 4 or user 4, sorry, we need to give it an IP address last usable. So let's look where PC4 is, user 4. It belongs to the largest network with 60 hosts, SW4. So the network address is this. This is the first usable, which will be the default gateway. Yeah, address of this remote site 2 goes upwards. And the last usable will be just before broadcast, which is 62. Yeah. So go to IP configuration, and I will copy this. And 62, I will change it to 62. Last usable. Broadcast is not usable, it is reserved. We can't use it. When I click out, so you can see this subnet mask is pre-configured, and I shouldn't accept it because we need to change it to /26. /26 subnet mask is 255, 255, 255, 192, isn't it? /26. And default gateway will be, for this network, will be this. The first usable, which we agreed to assign to our routers interfaces, right? So this is the default gateway for network to which this device belongs. If I just leave it like that, I think it should show there's completion 60%. Why is that? I must have misconfigured something. It may be the case. Last usable. I don't know. Maybe I made a mistake somewhere. Could be. So we can from user 4. We can verify from SW3 and user 4. And so user 4, click on it, go to command prompt and start pinging everything and see what happens. So where is my so let's ping. So what is the default gateway for user 4? that is the 10.11.48.1. Yeah, this is default gateway. Perfect. Now, what did we assign? What do we need to ping? Sorry. Well, we can ping anything really. So second usable, first usable is interface of the router. Second usable is the switch. So second usable should be this, number 2, 48.2. Will it work? Yeah, so switch, we didn't configure it, but it did reply to ping, which is good. So we must have done it correctly. What else can we ping from user 4? Shall we ping all PCs and see what happens? So user 3, last usable. Okay, last usable. So last usable here, which will be 110, right? This should be a PC. Is it going to work? It doesn't work. Something is wrong here. Come on. I must have made a mistake somewhere. So the PC on SW1 network, which is where is it here? So user 1 didn't respond. We can't click here. Can we? Okay, from we are still at user 4 PC. Remember, can we try to ping addresses here on remote on this server? Sorry, on this router. Pinging root addresses of router 2, remote site 1. Did I? No, I did it. No, I did it right. So it's all good. Should be good. Let's ping server routers. So ping 48.1.1.1.2.1. There you go. So this is the router interface, which we can configure, didn't we? What is the last usable? 122. Yeah. So routers interfaces are configured correctly. So, well, it looks like. So what's wrong? Let me just double check. So I will end here and I will say show IP interface brief. Is it all good? .65 is gigabit 00. Gigabit 00 goes up where 30 hosts are. Yeah, so switch to LAN. Yeah, so what's the problem? Show run. Let's check the masks. Maybe it's the masks. So 65 is /27. It is right, isn't it? And the one that goes down is where 14 hosts are, which is, so it should have this address 97, and it has 97, and the network mask is 240. This is right. 28 is 240, isn't it? So we couldn't ping user 1. Can we ping user 2? So user 2 should be last address on last usable on this network. So one before 95, which is 96. So pinging from here, 96. Can we ping 96? No, sorry, 94. Last before last usable, just one before broadcast, which is 94. Must have done something wrong. I don't know. I must have done something
Pavel,
wrong. Yeah.
sorry, I'm probably wrong anyway. You know, like when you set up when you added the default gateway,
Yeah.
do you have to do no shutdown for that as well?
Yeah.
Because there's one that you didn't do it on.
Did I not?
No. I sorry, but I was having brainstorm, so I don't know if I but I think there's one gateway that you didn't put the no shutdown command on.
No, it's all up and running. Look, up. Yeah.
Was there another gateway then? Because I'm sure there's one where you put in the default gateway and you didn't.
No. It shows up. You see, all up, all good. I'm not quite sure. I don't know. Why is it? What? It must be some sort of a miscalculation somewhere. Somewhere. Yeah. Sorry about it. I don't know. I can check. I've got the answers. But yeah, let me just stop sharing. I'll double check quickly, and I'll tell you. I've got some answers. Where are my answers? Right here. Usually I don't look at the answers, but must. So
Share those answer sheets as well, Pavel.
no, I'm not sharing answer sheets with you. I can't. It's impossible. I can look at answer sheets just to check. Right. So what's the number of this? 1193. Okay. Yeah, it's all good. From what I see here, 113 is the first usable, last usable. Yeah, 119, all good. All the same numbers. So I'm not quite sure, to be honest. Why doesn't it work? It should work because I'm pretty sure everything was correctly configured. So what is the switch 3, wasn't it? Well, but switch 3 doesn't matter. Oops. Because yeah, and even this was currently configured. Yeah, all good. So I'm not quite sure. I don't know. From what I understand and from what I see, it should work. Everything is correctly configured, and even the answer sheet tells me that yes, all my calculations are absolutely perfect. I don't know what's going on. I don't. So I don't know, guys. We can. There's always you can. Where does it say? You can check the results. It's in the packet tracer somewhere. Check results. What's the problem? IP address, gigabit, and subnet mask IP. Maybe because they swapped. Maybe because of that. So G01 and G00, because they are not clearly marked on the packet traces. So that's why possibly that is the problem. Yeah. So it looks like basically the G00 and G01, they should be swapped, it looks like. It could be the reason. Because of the, well, here it doesn't really say which one's which, and I can't tell. All right, so come here. Swap so basically this needs to be assigned to this interface, and this needs to be assigned to that interface. That could be the issue. Well, it looks like it. Yeah.
I
So
can't see your screen, Pavel.
oh, I'm sorry. Yeah. All right. Sorry. I'm talking in riddles. So like it wasn't confusing enough. Now you can't see the screen. So what I'm saying, from my answer sheet, so it could be that this should have that, and this needs to be assigned to this interface, because from the topology here, you can't tell which one is G01 and which one is G00, and that could be the issue. So all the calculations are correct. It's just the assignment wasn't correct. Yeah. So if I go and change the assignment, so basically all I need is just to swap like that. So conf T and IP address, oh sorry, interface G01, and IP address should be 10. IP address should be 10, 11. Oh, I can't. Okay, I will. No IP address. I need to say no IP address first, because I can't assign the same IP address to another interface. I need to. You understand? Yeah, one is so I need to. So if one belongs to one and the other one belongs to interface 2, so if I try to change them, swap them places, I need to remove one altogether, because otherwise you will have to, the router will complain. You can't have same IP address assigned to two interfaces. So I have to say no IP address 10, which one is that? G01, 114897, right? Yes, sorry, Subnet mask, 255, 255. 97 was what? That was 28. So this is 240. And now I need to go to the other one, and which is interface G00, assign this IP address to it. So I have to say IP address 10.11.48. Yeah, if I did it try to assign to this interface, it would complain. So 255, 255, 255, 240. Now this one will replace the old one on G00. And now I need to go back to G01 and give it to address of what was 10, 11, 48, 65. And so 65 is 27/27. So the subnet mask is 255, 255, 255, 19, sorry, 224, 27. Oops, what did I do? I'm trying to IP address. There you go. So now it should work. What about what is the completion? Show me completion. All I want is just to look at completion. Yeah, completion 100%. So basically, yes, because I couldn't see on the topology which one is which, and I just mistakenly assigned the addresses to wrong interfaces. Now I swap them, and it should work. So user, you can ping anything, most likely. So 94, what is 94? I don't know. There you go. So all the pings will work now, and completion is showing 100%. All right. So basically, let me just mark which one is which. So G00, so G01 should have 65. All right. So this is it. 65 should be assigned. So I will put it here. G0. What's it? G01 should have 65, and 97 should go to G00. Right. I should, yeah. Just double check and here and say show IP interface brief, and it will show what the assignments are. So G00 should have 97, and it works. Yeah, G00 is 97. All right, so here we are. If you wanna, I don't know, take screenshot. Oh yeah, this was addressing table which I missed. That's where all the addresses should go. Actually, sorry, I just missed it. You might take screenshot here if you like. If you haven't done so. All right, everybody. This is the subnetting. It will settle with you if you do your practice. Yeah, do your practice, please. What I have done, you just follow exactly the same and the same packet traces. There are some others which will follow after that, after this one, which is I think it's under module practice and quiz. There are more for you to do, like right here. There you go. So there's another packet tracer, design and implement VLSM addressing scheme. Very similar to what I've done now. VLSM design and implementation practice, and so there's one more packet tracer you can do on your own. All right. Thank you very much. Any questions?
Yes, I have a question because I didn't miss a lot of class, only 2 classes. However, shall I do? There is the workout. So do I need to submit this workout?